Thank you. We all know sometimes builders are perfect.
Sometimes.
Okay, how's that? Is that good? All right. Hey, before I get started with the actual presentation I put together for you guys, I did this inspection the other day. A gentleman I know called me up and said, I want to have a rough inspection. Builder said that you can come out on Thursday and do the inspection. Great. So he prepaid me. So I drive out there. It's about an hour away. And this is what I found.
Drywall in the garage.
Sure you're on the right line?
Yeah, there's drywall in the garage. So, how many of you like to give back money that you just got? So I was looking around and I was like, well, let's see what we can see. So I walked in, all right, there's the electrical panel, that looked all right. Drywall in the house. I'm glad I could go on Thursday and do it, right? So, walking around and everything's drywall. It's cleaned up, it looks great. I mean, beautiful job site. You know, foam around the doors, I can see some foam there, so, yeah, Jesus, it's looking all right. Upstairs, what's that?
You heard you were coming.
That's right.
I think so. I guess I'll step back here. Don't walk there. So yeah, I go upstairs, tubs are full of water, but there's a leak. All right, now wait a minute, there's a leak. And the builder saw me, and he said, he goes, well, we're a fast-paced company. We can't wait for a home inspector to get here. You're gonna ruin some drywall, I think, first. So, with that statement, it kind of irritated me a little bit, aside from the fact that I drove an hour to go out and look at drywall already in place. So I started looking a little closer, and we saw some more water. So it was definitely leaking under the tub. Water gauge, water lines were pressurized, and then I saw that. Now this ties in with our presentation some today. So, you guys know what that is?
Yep.
Foundation strap, yep. I was like, how many places do they install one incorrectly and the rest of them correctly? Yeah, it never happens. And that's what I said. The builder's rep, the sales agent, showed up with the client. And I said, yeah, I happen to notice this. That's installed incorrectly. So I have to assume that the rest of them are also installed incorrectly, because you never install one wrong. So went outside and then saw some erosion here going on. They don't do gutters. So here I picked up one of the straps outside. It was an MAB 15. So Simpson strap. So I knew the manufacturer, I knew the product. Now I know what the instructions are. So I went back inside and started measuring them, because you could see them right there along the bottom of the plate. There's my tape measure on it, and there it is at 59 inches. Now, how many of you guys know how far apart those things are supposed to be? 36? How far?
48.
48? What else?
Sometimes 6 foot.
6 foot? Anyone? The chart? Somewhat. Anyone else? Actually, all of those have been correct in the past. Simpson is now down to 32 inches. So the spacing on those is 32 inches. So 59 inches, that's not 32. 47, got better, still not 32. Then I started looking at nails on the drywall. What's the nailing pattern on an edge piece of drywall?
6 inches.
6 inches. That's not 6 inches. Well, one side of it is, but the other one isn't. So I started looking around a little more. Oh, look, in the field. What's the field nailing? Well, it depends. Are you doing single nail or double nail? 12 or 16? Well, look at these. These are at 30. Now, drywall can be used as a structural element, can it not?
Yes, sir.
It can be used for bracing. So, I don't know what they used for bracing on the exterior wall, but I'm certainly seeing this drywall is not even close to being suitably fastened for its own, to hold itself up. And it's throughout the unit. Every board was 30, 31 inches. they put just 2 nails in a stud. That's it.
Was it glued?
And if they luckily hit the stud. And even on the edge nailing, they're not even in the board. They're on the edge of the board. So I earned my money. Then we went outside and looked. What's the grade? It's grade of fall. Code requirement, grade fall.
6 inches.
6 and 10, 5 degrees.
Yep, 6 inches and 10 feet. You know what this one was? We actually found a 10-foot piece of siding and set it down. You know what it was?
0.
Exactly. It was 0. So we brought that up. The other side, same thing. And when you looked at the back hill, we had rills coming from the neighboring properties where water was being channeled down and eroding out the hillside. That's not going to get better. That can get covered, but it's not going to get better. So, all these things come into play when you're dealing with structures and potential structure failures. So,
Mike, can I ask a question since you're at that?
no. What, of course, what's up?
Of course, this being at a point before a final grade comes in, are you just citing something like that as a point of reference that this would be needs further evaluation at the completion point?
Yes, that's exactly right. Oops. Well, I just made everything go away. All right, so I'm a good inspector, but I'm not very good with computers.
No doubt.
All right, now I closed it by accident. Oh, no, there it is.
You got too much on it.
There we go. Yep, you got it. See, that's why we have Will. Will keeps us on track. So, slideshow. Come on, Will's computer.
Don't forget to introduce yourself.
Yeah, I will. All right, failure in construction. Now I pulled up a bunch of stuff. Now, I had an opportunity to teach a class in Alabama, and that's where a big piece of this comes from, because they were dealing with a lot of wind design loads and wind issues. So I thought it was pretty interesting. And one of the things that I wish ICC would give us a little bit more credit when we teach, because, I mean, any of you guys that teach know this, you put in godless amounts of time researching this stuff and putting it together to present to you. And a 20-minute presentation takes 4 hours to put together. So I got a big piece of this from that. But as I was putting it together, it made me start to think about buildings a little bit differently. Because as you're looking at what do they have to do, and then you look back at what we're doing, and it's like, man, if you can't even hit this, imagine what would be going on if they had to meet those requirements. And as you know, I mean, our environment is changing, whether you like it or not, or whether you believe it or not. So my introduction, Michael Nyer. For most of you, if you don't know me, ask your neighbor. But I've got 43 certifications from ICC and NFPA. I've been the building official for Dunwoody and Brookhaven, Chambly, Clarkson, Stone Mountain, Lithonia, Pine Lake. I've inspected in Sandy Springs. I've done plan review for Putnam County, Travelers Rest, South Carolina. I've done ADA work from Miami to Los Angeles. So that's kind of me. I like doing teaching. I've done a lot of classes, code classes. I was honored to do a presentation with your annual conference the last couple of years. I really enjoy putting these things together for you guys, and kind of because it challenges us too as inspectors to start thinking about this, and I love questions because it challenges me. In my past life, I was a residential and light commercial contractor. I had 3 guys working for me, and we did stuff all over our area and did everything from wiring houses to, and we were a turnkey company, so we did it all. So a lot of the stuff that I'm quoting out is stuff that I actually have installed. So anyway, so that's me. So wind, let's talk a little bit about wind. We want to get into some fun stuff here, right? So some of this stuff, excuse me, some of this stuff you guys will have heard or seen before, but I think it's important to re-emphasize it. so that, you know, it's important things. So you're going to see a couple of slides here that you've seen already, but that's okay. We're going to talk about them. So there, blew away the kids. So wind forces acting on a building. I'm going to turn this so I can see where I'm at. Talk to you guys. Got to have proper connections, not only between the roof diaphragm, but also the walls, all the way down to the foundation. We're looking for everything to be attached together. Now, so often when we do a rough inspection, we might go out and say, wow, there's a lot of wood here, you know, is everything supported right? You don't always think about, is it connected correctly? So that's some of the things we're going to talk about today. Some of the forces applying to buildings. Compression and tension. You know, we often think of wind as being a pushing force, but it's also a pulling force. When you've got low pressure on the outside of a building with the wind going over the roof, you've got higher pressures inside, and those pressures are acting on that building. They're pushing on the bottom of it. So, trying to push it apart. Well, here we go right here. So you've got, again, high pressures on the outside, lower pressures inside in this particular instance. We've got suction, the uplift on a roof. You know, so often we're talking about uplift resistance. And you think, what, a roof, how's it going to be lifted up? That's ridiculous. But, you know, I don't know, a lot of you guys are about my age. You remember that CNN picture that they used to have, that little video where the roof got peeled off the house? Yeah. It wasn't the wind getting underneath it as much as it was the wind running across the top of it, pulling it off that roof, off that building. So there's a lot of pressures that are acting on houses that we're trying to design for and take into account when we're building and then when we're out there inspecting. So these are some of the things that we want to pay attention to. Now this is a table right out of the code book where it talks about different zones, wind areas, and component cladding factors and stuff like that. So a lot of people look at this and go, yeah, I don't know. This is really here for designers. This is the IRC, most of the IRC is a recipe book. If you do A, B, and C, you can have a well-built house. The IBC is more like this. It's really set up for designers so that they can take into account what kind of forces or what kind of things they need to put into a building in order for it to resist those wind loads. And that's what this is. That's telling us what our wind design speed is and what kind of forces are acting on that building in those different zones. Well, you can see here, so we've got roof 0 to 7 degrees, 7 to 27 degrees, 27 to 45, and walls. And each one of those zones, 1, 2, 3, 4, and 5, are walls. Now I bring this up not because we're going to be designers, but because it helps you start to understand the way wind works on a building. So here are those areas. So you can see 1, 2, and 3 are the roof. 4 and 5 are the walls. And notice where 5 is. It's where our bracing is. The corners. Because that wall is resisting racking and was resisting wind loads. 1, 2, and 3. I think this is kind of interesting because when I started doing this research on roof failures during hurricanes, Zone 3 is a really major area where they have to do a lot of extra bracing. Sometimes they'll have to screw the roof deck down in order to keep it get it to stay there. That area takes a lot of wind pressure. Effective wind area, we multiply it by that coefficient in the table. And again, it's set up for designers, but I wanted to bring that up so that you can start wrapping your head around how wind acts on a building. When we talk about exposure categories, that's something that in the home inspection industry, we don't really deal that much with exposure categories, but on the municipal level, we do, right? You got your municipal guys out there. We deal a little bit with exposure categories and what kind of exposure is that building in, because it affects how you have to build or design. Exposure A, large cities. You got high rises, tall buildings. We were just in New York. I mean, there isn't anything low rise. I think, so wind acts differently in an environment like that than it does in exposure B. This is what we were dealing with 90% of the time, exposure B. C, open farmland. We've got a little bit of that here. But that barn and that house, how much wind do you think's hitting that as opposed to B? Probably more, right? D, how much wind's hitting that house?
All of it.
A whole lot more. So now I bring this up because as inspectors, when we're looking at wall bracing, we've got to think about, where are we? Are we somewhere in between? You know, a subdivision being built, the first house very well could be C. The last house falls into B. But what are we dealing with? What kind of exposure and how much bracing do we need based on that exposure? So you've got a table in here for height coefficients and adjustments. So what's your roof height? Now I know this is getting kind of technical and you guys are going, God, this is so early for this shit, Michael. But one of the things is, I mean, when you're dealing with these houses, and Raul, I think you can appreciate this, we dealt with this in a city that we worked together in. They made a revision to their ordinance that they could go taller with their roof. Well, one of the unexpected consequences of that, or unintended consequences, was now that you're taller with your roof, you've got to take into account more bracing. What? Well, you can't even get the bracing right on the short ones. So, you've got to add in a little more bracing based on, again, notice your exposure category, B, C, or D. Now, most of Brookhaven is B, but nonetheless, we still have to add in a little bit more. You can see, if you've got a 30-foot roof height, or 35-foot, you're 5% more bracing. Well, that doesn't sound like a lot, but when you're dealing off of that table, 5% can mean a lot, as you're getting into it. So, you guys remember this picture? This is my favorite picture. Not to pick on any jurisdiction, but it was passed like that. And I brought it up. And they said, well, you know, the county already passed this. I don't care. This is still wrong. So, anyways, some definitions. So, when we're talking, you know, one of the last things you want to do is out there in the field and talk about something and say something incorrectly. So, we've got some definitions that I want you guys just to be aware of. We've got braced wall lines. That's a straight line through the building. Braced wall line continuously sheathed. Now, for the most part, we're talking about OSB. Continuously sheathed, braced wall lines. Gives us a lot of structural strength, and that's all surfaces, right? Not just the walls. That's up in the gables, that's over top of headers. A header, that's solid wood, doesn't matter. That bracing, that plywood, adds to the structural integrity of that wall. Braced wall panel. Now we're breaking it down. Now we've gone from the wall line, which, I don't know if I've got this in here, but if this is our braced wall line, we can offset it 4 feet into the structure, so we can take into account both of these walls. You know, if I'm using the stage, pretending it's so. Work with me here, guys. Stage is part of the building. We've got to, so we can take our 4-foot line and move it out so that it's outside of the structure. So we can take into account this corner as well as that corner and be a part of our braced wall line. So now we've got our panels. Now we're dealing with the individual panels. So when you're talking about these, now, and then shear wall is something completely different. So be careful about mixing up those terms. Diaphragm, that can be a horizontal system. So the roof diaphragm The decking on the roof can act as a structural element to resist racking or resist bracing, or add to the bracing. The floor diaphragm can also do that. So if you're dealing with 2-story on a slab, and you've got that floor diaphragm in there, that plywood is actually acting as a resistance to that wind, if it's built correctly. Shear wall. So shear wall is a general term, but typically what they're really referencing is something that's designed. If we have an engineered product come out, for instance, so garage portals. Simpson has a shear wall panel that you can put in a garage portal that's down to, I think, 12 inches. But it's a designed product. It's got bolting across the top, it's got a panel, it's a steel panel that goes in there. You can add some wood in there so you can fasten your stuff to it, but it's a designed product. They can use this in the house, but it's a shear panel. Framing. One of the things with framing, and again, you know, just as I was putting this together for those guys, I was wrapping my head around it. It transfers all gravity, uplift, and lateral loads to the foundation. So a lot of times we're thinking of it just, well, it's just holding everything up. Well, no, it's actually transferring all those loads down to the foundation, and that's why the foundation support is so important. Framing systems consist of the roof deck, exterior and interior load-bearing walls, beams, girders, posts, and floor framing. So that's our framing package. It's holding everything together. Shear walls, braced panels, they provide strength to resist the lateral loads that are acting on it from the environment. And then the integrity of the building. It comes not just from those components, but also from the attachment of those components together. That's why that table 602 out of the code book, our fastening table, is so important. I mean, so often we forget to look at that. And I'll admit, there's been a couple of cases, and we'll talk about that, but you know, look at that fastening table. Be familiar with it if you're going out to do a rough inspection. I mean, shoot, print it off and stick it in your back pocket if you want. Yeah?
One frustration I have, and maybe I'm wrong, is I try to figure out why something's in the code book. You know, your commentary books and your National Electrical Code handbook, it kind of drills down why this is in there. I've called the state of Georgia, and they go, we didn't adopt that book. We didn't adopt the commentary books. I'm saying the same people write it, so this is kind of telling you what they mean by that section. Am I wrong in that or what?
I agree with you, and I don't understand the concept behind it, but I actually had the opportunity, and if any of you ever have the chance, and I know some of you have, but if you ever have the opportunity to sit on one of these code advisory boards or on an exam development committee, you learn a lot about the code process. And the people that put together the code are people like us. So we've sent in amendments and they vote on them and stuff like that. So everyday people, contractors, inspectors, engineers, put together the code book from a cumulative thing. The person that wrote the commentary are 2 engineers. They think, and that we're a part of the process, they think they understand all of the nuances of it. They're really, 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 really close. But the state didn't adopt that because that's not the code. That's just what they think it is. So you got to.
But they're kind of explaining what that section of the code
It is. And if you call up Ted Miltiades over there at the DCA, he'll pull out the commentary and go, well, this is what we think it says. Because it's really, really, really close.
No, they won't. You call the state, they say, well, we don't want to get involved. You need to talk to the county inspector.
Well,
inspector. We want to wash our hands of it.
Yeah, but I mean, they'll give you some guidance on some things, but they'll use the code commentary. I almost went to work for them, so. But anyway, so let's see, what else we got here? So larger homes with large openings, they may also have interior shear-bearing walls, shear walls. Those walls could be just comprised of drywall, but they have to be nailed in a certain way. But that may be a factor in our looking at a house. So if it's a shear-bearing wall or a load-bearing wall, shear wall, if you're looking at a load wall, what are you looking for? Header, come on, you guys, you know? Headers, nails, fasteners, yeah, there you go. So you're looking at that. A shear wall, what are you looking for?
Bracing, has a brace.
Very good. Yep. What kind of bracing is there? How's it fastened together? Is it attached properly? Is it constructed properly? So the edges or ends of diaphragms are the critical points. We'll come back to that. So when you've got structure, the wind forces act differently on it. You can see you're oftentimes, again, we're looking at the wind loading, pushing on that structure, but it's also downward pressure and it's also upward pressure because it's trying to pull that building over. We've all seen the picture where the building tips over. Same thing. That's what's going on there. Now, if you go to the coastal region, this is what you're looking at for attachments. Now, let that just sink in for a second. Notice, working from the top, we've got bracing, or straps that wrap around those trusses to hold them to the top plate. Then we've got attachments from the top plate to the studs. We've got attachments from the headers to the studs, and then from the studs to the foundation, or the floor and then to the foundation. So all of that building is tied together to hold it in place. A little bit more than what we usually look at, isn't it? But once you see that, then it's like, okay, now how important are those nails in the trusses that we're looking at? If they've got to do this, and we've just got to do nails, how important are those nails? They're pretty important. So wall bracing. Again, like I said, I know some of this you've heard before, but again, I think it's worth repeating. Because we're talking about framing. This is a structural class. And why do buildings fail? This is a part of the reason why buildings fail. Oops. Has to start within 10 feet of the corner. So if this is the corner of our building, within 10 feet we've got to have our first structural brace. Then every 20 feet after that we've got to have a structural brace. Now with continuously sheathed buildings that we're seeing right now, that's a little bit easier to achieve. But I was just out in a house 2 or 3 days ago. Corner of the house, window, 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 window. They wanted it, yeah, but I'm looking at it going, that's almost 20 feet before we even get our first braced panel. And that one was only 22 inches wide. So, you know, it happens. And this particular instance, it was the first floor of a 3-story building. So how much weight is on that? A lot. That wall is integral to support those other 2 floors above it. So everybody's seen this one before, but again, I think this is worth repeating and worth illustrating. You can see, this is a diagram right out of the code book. Code book says we want panels at the corners, maximum 20 feet. Look at that, 20 feet gets around your garage door. So you got a panel on each side. Ooh, how about that? At the bottom, you can see we've got braced panels on each end. We've got 20 foot in between. Doesn't need to be necessarily braced. Yes, sir.
When you're getting ready to go build a house and the builder takes a set of plans that somebody drew to a building supply and they run it through the computer system and they come up with a laminated beam, are you assuming or do you know that that computer design takes this into effect?
On a municipal level, no. If I saw a laminated beam in something, and I mean, I think the guys that are working in the municipalities here can agree with me. If you see a laminated beam in something, we ask for an engineer letter. Because it's not fitting in the recipe book.
Right. But do you assume that they have the narrow wall bracing built into their computer model?
I assume nothing. If it doesn't fit in my recipe book, that's called the IRC,
Right.
you gotta give me an engineer letter. I'll get, to kind of play off of that, I ran into one, or the garage panel was only 11 inches. It was just a garage. I mean, nothing above it, just a roof line, 11 inches. And I said to the builder, I said, you need to have an engineer letter on this. And he comes back to me and he goes, well, I'm gonna have to thicken up the door jambs. Well, you made it too narrow. Because the engineer came back and said that for that particular design, because the garage actually stuck out from the house a good bit, and it was real narrow on the corners, he made him put 3/4 inch plywood on the inside. So 3/4 inch plywood inside to help brace that up, to keep it from racking. Now, on a home inspection, coming out after the fact, we can't see that. That's not something that we can necessarily pick up on. Unless you were there for the rough and you know that it's supposed to be 3/4 and you can go over to the jam and go, where's your 3/4 inch extension jams? Because the wall, the drywall, the extension jams that come with the windows and doors are spaced for 1/2 inch drywall. So then they'd have to add to it in order to make it a little thicker. So, yeah.
So if we're seeing houses that deviate from this, should we be asking the builder to supply an engineering letter?
I would.
Okay.
I mean, even on a private inspection. Now, here's the thing too. There's a point where on a final finished product,
I mean pre-drywall.
yeah, pre-drywall, on a finished product, I can't know what's there. If I wasn't there for the pre-drywall inspection, I'm not gonna walk down that road because it's just too much of an argument and just, oh yeah, we got plywood in there. Really? Okay. I gotta take his word for it. I'm not drilling through the drywall to look at it. So, I mean, there is a point where you gotta kind of play with them. Yes?
Mike, of course, it's, those who agree with IRC, there's narrow wall directions in the IRC for that, and then Simpson makes a pre-manufactured wall structure for that type of condition, the narrow wall.
Yeah, and that's what I was talking about earlier. Those, they're actually shear wall. Those are called shear wall panels because they're designed for that. So, yeah, and in a final product, you can't see that. You don't know if it's there or not. You know, there's a time and a place for bringing up stuff, and a final wouldn't be the time or the place for those kind of conversations. So minimum number of braced wall panels. Walls less than 60, braced wall lines with a length of 16 feet or less, minimum of 2 panels. So, well, I mean, if you think about that, so it's got to be within 10 feet at the end, within 20 feet. Yeah, you're going to have 2. Because if we've got 16 feet across here, but 10, within 10. Yeah, you can't have it just in the middle. It's not going to be big enough. So, under 16 feet, you could probably potentially have 1. Along the braced wall line, A and B, we should use our table. Yeah, okay, here's our table. This is the one that we're using all the time. We're, for the most part, we're in design category B. So, you know, and here's another question for you guys. And does anybody know what our wind speed here is?
90.
90? That is correct. We are 90. So when we're doing design, and we're actually going to see later on where something that we're seeing every day out there in the field is being required and asked of when it's really technically not required here. But anyway, I digress. So anyway, your bracing table talks about the different types of bracing that we've got. We're dealing with continuously sheathed wood structural panel, CS, WSP, they're on the end. So whatever condition we're in, are we in the first story, or the top story, or the 3-story, or whatever? Are we on the second floor? What are we? What condition are we? That's going to relegate how much bracing you need. If you look over here at the end, you can see what's our braced wall line spacing. You can see how much this is how much bracing we need. 3 feet, or 1.5, 4.5, whatever it is, based on that condition. So going back to our illustration here, you know, that's 4, 8, 12, 16, 18 feet maybe from corner to corner. From this corner to that corner, 18 feet. So we'll say 20 method. Well, it's not continuously sheathed, is it? That's not continuously sheathed. This isn't structural.
Oh, I'm sorry, I thought that was house wrap, I can't.
No, that's a foam board.
Got it.
Yep. So that's not a structural panel, so that doesn't qualify for continuously sheathed. Wood structural panel, right here. So 20 feet, we gotta have 3.5 foot of bracing in the wall line, whoops, 3.5 feet. Well, we've got it right here, but it's all off on one side. This has been compromised. Those corners are less than 2 feet. So we don't have bracing starting within 10 feet of the corner. So if we take into account our exposure category, and you can see this is the first story of a 3-story. 3-story structure, and B, we're still at 1, so again, we're still at 3.5. Roof to eave ridge height, that's a pretty good roof. I'm going to guess that the upper one's about the same. So let's say it's 15 feet, so we got to have 30% more because of the roof ridge height. Oops, wrong way. And then wall adjustment. What's the height of our wall? Well, these are, the lower one are 9-foot walls. So where are we? 9 foot, 95%, so we can drop back a little bit. Number of braced wall lines, any story, we've got 3 in that one. Additional 800, nothing. We don't have any of these in there. These weren't there. We could have reduced our bracing if we had hold-down devices on our framing. First story of that building was to be unfinished. Got to have 40% more bracing. So 3.5 times 40 is roughly what? 5 feet, 5 foot of bracing. Now, notice here, if we had added gypsum board, 4 inches on center, nailing pattern, that would provide structural resistance for that building. So, first floor is unfinished, we're short at least a couple of feet of bracing. We don't have anything within 10 feet of the left side. And no drywall inside, so, I mean, we've got a problem there. The first floor is short. The second floor is actually missing a panel within 10 feet of the left side, so, because 10 feet, because again, you know, you've got 4, 8, well, if we go up here, 4, 8, 10 is probably right about there in that window. So, I mean, these are things you got to start kind of looking at and wrapping your head around a little bit. And then minimum lengths. So you can see here, now, so what they did with the code is they said, all right, everybody, when you build a corner, it's got to be 4 feet. It's got to be 4 feet wide. Then they said, well, we can reduce it. So we started out with a 4-foot panel. You see 4 foot, 4 foot, 4 foot, 53, 58. So the taller the wall, the more wall bracing you have to have. So when you start taking that into account, then they say, well, next to certain size openings, we can reduce that panel. Now, the top of this got cut off a little bit, but on a 9-foot wall, there are 27 inches. 27 inches is the narrowest panel you can have on a 9-foot wall to start to count for your wall bracing requirements. So 27 inches. I'm running into a lot of them that are 22. And you may think, well, is that really that big of a deal? It doesn't fit in our recipe book. Our recipe book has 27 inches to that first window or that first piece of bracing that we have. Anything under 27 inches doesn't count. So going back to our picture, those corners were they were under 27. They were only like 26. They were, no, it was the other side, 22. They were under 2 foot. So they don't count for anything. If they had been at 27, well, then they could start counting. 27 inches, 27 inches. So, oh yeah, there you are. So you can see that it's over halfway on this panel is probably right about there. Again, about into the window. So that panel doesn't count for anything, even though it's there in the corner. Yeah?
Don't you have to continue across the floor levels?
Yes, you do.
Okay, so even if those windows weren't there,
Yeah, and this is actually still a problem because you don't have anything tying these two walls together. You're right. And I don't think this is in the 12. It was in the 6. This corner had to overlap the stud, the plywood. The OSB had to overlap that stud. But I don't think that's in
they're
there.
staggered.
Yeah, well, it has to tie that wall together. But I don't think they carried that over in this new section for whatever reason. But yeah, so, and to your point, this is a failure point for houses, where the wall plates tie together with the floor. So if we have foam in there, well, what's tying it together? God, I hope some nails. Oh, here, partial credit. So panels between 36 and 48 shall be considered a braced wall panel. We can get partial credit for those. And then this is how much credit you can get for each one of those based on, and notice a braced wall panel 36 inches or less doesn't count for partial credit. So that 27, I misspoke earlier, that 27 does not count as partial credit. It counts as a braced wall point, but it doesn't count as partial credit to add up. So there you go. So again, when you're dealing with continuously sheathed, it's above and below windows, and it's even the panels that are not considered structural panels. Again, this is right out of the code book. So here we've got one, kind of a dark picture, but I think the windows say a lot. Now this is a final that I was doing, a resale, that I have to notice this on. Now, I didn't bring this up because who's going to fix it at this point? The builder's long gone. But I noticed that they've got so many windows in here that they've got no structural bracing at all in this basement that's unfinished. Now, what can happen if we don't have bracing there? Anybody? Yep. It could collapse, yeah, in an extreme situation, but it certainly could rack. If it racks, do those windows open? Probably not. If doors open? Maybe. They certainly might rub on the jamb. Things we might notice later on. Here's another one that's in construction. This is a little jut out. Where's the brace panel there? There isn't even anything that's 27 inches there. Now, this particular addition on the back of the building, you might think, well, the building is providing some bracing. This particular addition was 12 foot out. So it's not within 4 foot or 8 foot of the wall, because again, we can offset 4 foot and capture 4 feet on either side. It was 12 foot out, so it's its own little addition, and it has no bracing at all. Nothing to hold it square. Yeah?
Michael, the thing that draws into question, we're not here to try to create a solution. I mean, obviously, we're citing conditions based upon what the book says. The issue comes about is when the home buyer, in this case, or what's in their mind? I mean, how do you, the correction process that's then taken back to the designer, the builder, and so forth in that process. We see this kind of thing, a fair amount, and we don't necessarily always draw it to question, or maybe we do draw it to question, depends upon what the situation is. But the corrective action for something like this, I mean, if this is engineered in some respect because additional elements that you don't see in place that a designer or an architect might have built into it, you're basically commenting about the fact that this wall has this extension, you have these windows that interrupt what would ordinarily be considered a bracing system that would help to stabilize the structure element at that point, given certain conditions in place. What you're doing in this particular case is drawing the attention to the construction of the piece by the builder to let them know that this doesn't conform with what the current code book references or requires. I mean, I fully understand where you're going with this, and I struggled with this whole entire thing when I went through the code class for structure, as to when you start citing these types of things to builders, you're leaving it in their laps as, you're responsible at this point. I'm just letting you know, this is what the book says, this is what you have.
Yeah, that's correct. And, so the two shoes that I've worn, municipal guy, you need an engineer letter on this because it doesn't fit in the recipe book of the IRC. Private inspector, you need an engineer letter on this because it doesn't fit in the recipe book called the IRC. I mean, both of them, that's the only thing that we can really say, because I'm not going to come in here and go, well, if you put another layer of 3/4 inch plywood or 1/2 inch plywood on there, nailed it 6 inches on center, you should be okay. That's not me. That's the engineer. So, yeah, these
Yes,
guys
sir.
are first, I'll get back. Yep.
Yeah, so your client that's having this house built and asked you to come out there and do this inspection, they wanted this room addition, they wanted this sunroom added on.
Yep.
Yep. So you point out all this bracing issue to them, and then they ask you the question, how important is that?
How important is it for you to open your windows? Of course, windows aren't really a structural element, so if it racks and the window breaks,
But in your 30 years experience, have you ever seen that really come into play?
I have. I've run into some that have cracked. Some windows that, how many windows have you gone to that don't open? A lot of them.
Well, that's a wood window for you, period.
It could be, or it could be just that window being racked. I've seen plenty of them where this corner's tight and this corner's got a gap.
Well, I'm just playing devil's advocate.
Sure,
because
sure,
the client wants a sunroom.
Yep. Now, there are alternatives. And as an inspector, you want to say to your client, look, it's not all lost cause. The builder's going to go back and talk to his engineer. We've got a floor up here that can act as part of that diaphragm. We can't take that into account because the IRC assumes that it's there. But there's a floor up here that the builder can take into account for the bracing method. The engineer can design that in, and perhaps that's adequately braced if they nailed that plywood down adequately or whatever. But we'll let the engineer call that out. Yeah.
But I'll bet you all the money he has that's going to be built exactly like it looks.
Yes.
Possible. Yeah.
Was that room permitted?
It was. This was a part of a whole house. Yeah.
So this is an inspection during the building construction?
Yes, this is a
If
rough.
you would inspect, like earlier, we talked about inspections for houses that are for sale.
Yeah.
So you would see something
If
like
this
that,
is drywall,
completely finished and everything.
I ain't going there.
mention it, right?
I ain't going there.
Because you would raise concern of the buyer,
That's all correct.
and then they would make them tear it all up just to show it's all there.
And who's gonna fix it?
Exactly.
Yeah. So if there's drywall there, nah, I ain't talking about it. Yeah.
I think the important thing to remember is you gotta report it. You put the buyer on notice, and it's a matter of record. So whether the builder fixes it or doesn't fix it, or gets an engineer to look at it or doesn't, It's a matter of record. If something happens in the future, people can go back to the report, and then the builder has to explain why
At least
he's
you
given
did
due
this.
notice and he did nothing.
At least you covered yourself. Yeah.
Exactly.
Like the 9-year-old house, very similar to that in Sutherland. And none of the windows were broken, but they were very difficult to open. And the only windows that were fogged in the entire house were those. And I see the relationship.
Yeah, I mean, and it's, you know, is it something, is the house gonna collapse and fall down on itself? Probably not. But, you know, could they put a water bed up in that alcove? Because this was above I think there was a master bump out on this. Could they put a water bed up there? Yeah. Could that affect the structure? Yeah. There's a lot of weight up there. So, I mean, you know, these are things that we can't really anticipate, but like he said, we've made him aware of it. You want the addition, that's great. Let the builder prove to you that it's okay. Because I can't get it to fit in the recipe book that I have. Because we can only inspect based on the parameters of the IRC. So, all right. Well, that was fun. I'm glad to hear some of you talking. Here's another one. We talked about this one last time. No bracing in this wall whatsoever, all the way over to the other side of this door. And the client said, does anybody remember what the client said?
The county passed it.
Yeah, well, the county passed it, but
Yep.
yeah, somebody said it. They wanted the extra window. This wasn't the approved design. This was not the approved plan for this house. They asked the builder for that last window on the end.
What extends beyond it? Because you can obviously see
Carport.
it's a carport.
Yep. So they wanted to be able to pull around and be able to see all of the carport.
So the carport in essence is open on both ends?
Yep. Yep. So, you know, and I'm looking at the client going, well, you screwed up the design, but let the builder prove to you how he's going to fix it. Their engineer came back and said, put 3/4 inch plywood on the inside, nail it with a 4-inch nailing pad. 4-inch nails. So she asked me to come back. They were drywalling. And the builder looked at me and went, I'm going to get the plywood right now. So, you know, whatever. She turned to me and she went, he wasn't going to go unless you came. Well, I'm glad I showed up. That'll be $150.
Yes.
That's darn right.
Here's a brace wall panel. Again, illustration right out of the code book. It shows a hold-down device. We're starting to see those now because you can reduce your bracing a little bit with those. Here's another one too. This is another hold-down device that's fastened in with an anchor bolt. Those are pretty nice too.
I don't see the nailing.
And you can see, you know, the panel length is in accordance with our table. They've got a table so that you can reduce that panel. And you've got these 2 hold-down devices, that plywood on there. That whole panel is now technically a little designed feature that fits in the IRC now that we can use in lieu of a 4-foot wide panel. I did one time where I called out the builder on too narrow of a panels along a patio. Called up his engineer, and the engineer had him come in and do, it was kind of a cheesy version of these, but do these on every stud. Fasten them down to the concrete slab with redheads. Well, if he's going to sign off on it, okay. Let me have a copy of the letter. Took a picture of it, put it in my report. That was good. Because that was another situation where I came back and did a re-inspection. I don't do that very often, but once in a while. But that was for a doctor. Garage portal openings. We're all familiar with this illustration. Remember when it came out as an add-on because some houses laid down on their foundations during a microburst that we had in North Georgia. But you got a 3-inch nailing pattern around the perimeter, 1/2-inch plywood over the base of the sides that overlaps that header. Because if you have that break in the plywood right here at the header, what good is it doing? It doesn't do any good. So you want to have that lapping up on that header with a 3-inch box pattern up at the top. 1,000-pound strap on the inside, so we want to have that strap covering, tying. Again, think about that picture that I showed you earlier, what they're doing on the coastline. We've got a strap that's going from the studs up onto the header. Same thing that they were doing at the headers where they were tying those straps down onto the studs. You're tying those back together, holding those pieces together. A lot of times you'll have these headers will rock. They'll rack up and they'll start bowing out one way or the other depending on what you put on them. I had a builder one time who was putting the steel lintel on it with brick, 1.5 stories of brick on it, and it made that header twist. He had to come in and do all sorts of extra bracing for it.
That strap doesn't need to go up to the top plate.
Uh-huh.
It does.
Yep. Now you can break it. They could have one that goes from the top plate down onto the stud and then from the stud down onto that'd be fine.
Inspector, the CBO in Woodstock told me they didn't enforce it.
They don't enforce it, but it's still in the code book, isn't it?
Yep.
Well, that's when you just kind of look at it and go, well, the code was adopted in 1991 under the Uniform Code Act, so that Georgia is under the same code. So what state are you in?
This was just made.
Yeah, I know. I like to be an idiot sometimes. Because then the building official gets mad at me and he goes, fuck you. Sorry, that was inappropriate. I shouldn't have said that about it. I'm not always politically correct, sorry. Yes, sir.
One thing I almost never see are the required anchor bolts, 2-inch washers and nuts. Almost
Yep.
never see. So when they're not there, what's the retrofit? What can they do to make that anywhere close to right?
I write it up. One of the things that they can do is they can come in, well, they could get an engineer to design a correction. That's the short answer. The longer answer is I've seen a lot of the engineers spec redheads where they can drill those in. Are you familiar with those?
Yep.
They're those, they drill the hole, and they drop the anchor in there, and they hit it, and it mushrooms out inside the concrete. They can put a washer on those. And usually if they've got one that's missing at a shear wall panel like that, you'll end up with 2 of them with a washer on. So, yeah. Now, going back, yes, sir.
With the redheads, one problem we run into is we'll allow redheads when there's a break in the sill plate.
Mm-hmm.
In the bolts line.
Yep.
Suppose those want to go out by 3-inch redheads.
Yeah.
Like, okay, you're required to be 7 inches in the concrete.
Mhm.
How do you think a redhead retrofit's going to work?
Yeah. Well, you know, the one I really
And you
like,
can't check it.
I actually was out on the inspection and they were correcting the inadequate fastening. So they were going to use shot nails. So the local jurisdiction said, yeah, you can use shot nails, just follow the instructions. So I'm there with my client, we're walking the rest of the house, and the guy shows up, fixes it. And he goes, wham! He's driving them with his hammer. They're 2-inch. Well, what the heck's that gonna do? Ain't gonna do nothing. It's, because the plate is 1.5 inches, 2 inches, it's only going into the concrete, maybe a 1/2 inch, because you got a little sill sealer there, so maybe 1/4 inch. And he's driving them with his hammer. Well, I took a picture.
Cheap.
I said, well, talk to the building official about it. I can't do nothing about it. So kind of to your point, you've got your anchor bolts tying in. You've got wood structural panels. Look at the plates that they've got tying those walls down to the floor system. You can also use wood structural panel sheathing. So to your question about this having styrofoam there, I mean they could have had something like that in there. Possible, but back chance. I would have been, based on everything else they were doing, I would have been really, really, really surprised if they did that. And then the ends of your braced wall panels, again, we're looking at, sizing based on hold down devices. they can add these hold down devices in there to reduce their bracing, because they've got too small a bracing, a couple other, that they're adding to it. Now, here's something that I've looked at this picture 100 times. Yeah, this picture 100 times, and I've never noticed one thing. Nails. 3 16-penny nails, 16 inches on center. Let me ask you, and be honest, guys. How many of you have ever looked for nails in a bottom plate? I've never, ever looked for nails. Never even thought of it. I assumed they're there, but you got to have 3 16-penny nails, 16 inches on center. And if you've got an interior load-bearing wall, look what the requirement is there. Same thing. It blew my mind when I
But they're
noticed
not
that.
using 16.
I never thought to listen to it.
They're not
Yeah,
using
it's 4 and
16.
6. 602. I'll get you close. It's probably 602, 10, 11, somewhere right around there.
Got an issue of advanced.
Well, get out your code book. Move it. Anybody got a code book?
At home?
Nobody has a code book? Sorry, say it
What's
with
it
that.
about printed books anymore? It's
Well,
on
some of the
computer.
advanced framing I'm looking at, pre-rise, I'm seeing that.
It's in there. It's in there.
Aspect of that wall frame, load points.
Uh-huh.
Is that I'm seeing single top plates.
Yeah, single top plates are allowed. Actually, single headers are allowed, if you get right down to it. But yeah, single top plates, as long as stuff is aligned,
Right, how far off deviation?
1.5 inches.
Okay.
Same thing with your rafters coming up. They can be offset 1.5 inches on a ridge board. Oh, sorry. I can't hold it very long. Come on, I'm getting up there.
Put that into the.
All right. So again, here's, and again, if our
Take a
interior
text
wall
call and hammer to
is a
pull the
braced
nails
wall
out.
panel,
See if it's a
or
16.
a bracing panel, we have to have
Or
blocking in
if it's
there.
12. Strip.
Again, something I missed that. You can see this one here where they run parallel. We got to have an additional floor joist under there so that we can have something to fasten to. Makes sense. Just shot right by me. Never really caught it. And notice along the top, 8D nails, 6 inches along the panel. 6 inches on center. If it's a braced wall panel, we really want to have those things nailed in there.
Not gonna find it.
Connections to roof framing, top plates. Oh, this is one you're gonna have fun with. Let's see. Locking are required over openings. Yeah. Size and design. Yeah. This is the one that I want. Oh, this gets into solid blocking between rafters. So this goes like if you're talking about bracing. You need to start bracing the roof. As you're coming up that wall, the roof needs to be braced as well. So we've got solid blocking requirements for some of the rafters, attachments, soffit panels, where it exceeds 15.25 inches. So now, the energy code, now this is something that's really going to hit next year. And you'll probably see some more of this come about next year. So the energy code has changed, or is changing, has changed. R38 insulation, right? In the attic. What's the exception? Crosses the top plate when you have raised heel trusses. Well, if we do a really tall raised heel truss where we've got 15.25 inches in it, over that top plate, we've got to have blocking in there. Here you go. Look. Your shear wall panel, or your braced panel, needs to go up into that truss and provide bracing for that truss, the ends of the truss. So this is something that we'll probably start seeing a little bit more of as they start doing those higher trusses. But again, 15¼ inches, I mean, that's pretty tall. But very likely, we can see that.
You're gonna get there.
And you can see the panel, it goes up and around those two trusses. So there's your 4-foot panel, spans around 2 trusses, and keeps that from racking.
Spaces on that, is that every truss?
No, the spacing on it would be with your brace panel. So you'd have one within 10 feet in the end of the corner, every 20 feet after that. So, this is something fun. So, where the uplift force does not exceed 200, and the wind speed does not exceed 90, is that us?
Yes.
For the most part, that's all of Georgia, almost all, except when you get down by the coast. Category B, roof pitches 5 and 12 or greater. Span is 32, rafters not spaced more than 24. How often do you see some rafters spaced more than 24? I mean, so we can have attached to their supporting wall assemblies in accordance with table 60231. Table 60231 we've already discussed, and it is our what? Fastening cable. God, you guys weren't paying attention. What's wrong? Got you when you were sleeping. So 60231 is our fastening cable. So what that says is trusses can be attached to the top plate in accordance with the fastening cable if we don't have a 200-pound uplift and we don't have a wind speed of 90 or more, which is us.
In southern Georgia, what is the line start at?
Oh, I don't know.
You know, we had a category 2 come up from Albany all the way across
Yep.
75 lane.
That's true. But for our design speed, it's still 90. So this says that we can attach trusses to top plates using the fastening cable. Fastening cable has specific requirements. Let's see, where is it? Rafter or truss to top plate. Toenail. 3 16-penny nails or 3 10-penny nails. 2 nails on one side, 1 nail on the opposite side of each rafter or truss. Now, does that say anywhere where it says it has to have hurricane clips? Didn't the code just say we could fasten in accordance with our table?
Mm-hmm.
Where's hurricane clips? Now, to be fair to the jurisdictions, there isn't a municipal guy out there in the world that gets up there to look to see if there's 3 16-penny nails into a truss. Because, number one, they don't have time to take a ladder, go up, yep, yep. I mean, and we don't have time. That'd take all day to look at that. So what's easier? Hurricane clips. I want hurricane clips on every truss, or every other truss, whatever they want. Doesn't matter. Every third truss, who cares? It's fastening it down into something you can see from the ground. Yeah.
Whenever I knew that as a required version, that's already, the guys tell me, oh, they're nailed, show me. They are never nailed right.
Yeah.
They're gonna put on her.
Yeah. Yeah, and I mean, it's easy. It's easy to see. They don't add that much time. But, you know, again, I mean, to go out and say, you have to put them on, we don't have a code that says that. Not anymore. What? Oh, we need to do a break? Okay. All right. No, that's just for you guys. Don't tell any of them. And for the municipal guys, like I say, I appreciate you being able to walk in there and go, they're tied down, they're nailed down, we're good. So, all right, let's take a 10-minute break.
You know,
Stretch your legs, wake up.
3 nails in yellow pine.
Sure.
At one point, the lower roof has to have a pitch on the low. No matter where it's at.
Free market, it's almost illegal. Free market, it's almost like it's designed like a firm, it's like a adjusting firm, that's kind of like So how does the catch basin that still be profitable? I just got somebody probably had to for what? To go after that market. Like you're saying. Go after to do the inspections. They've chosen one independent company. So that company started for this? No, it was out there. He's a business owner. Yeah. It's a lot of, that's a lot of crazy, but yeah. Yeah, and then they're going to take them all that business away from that businessman and bring all the inspectors. So they're going to have in-house inspectors, financing, in-house their own realtors. It's crazy how they make money on the finance. It's got to be close to this. Like we started talking about a year ago, a lot of these buyers are going online. There's somebody that's buying a house online. Yeah, they don't have anybody to look. They don't have any records. All the I'm on the phone, it's like unlocked on the phone. Yeah. I mean, I called the number and like it'd be faster than opening up my I'm running some of these
That's all bad for you, George, nice to meet you. Yeah, we're literally go out do I have to? I was a crooked when they did the stuff. I was the startup on the I'll tell you, 1027. It's like a oh,
I know I'm going to get it. Yeah, it's going to happen.
Yeah, I mean, they were more, I mean, the concept is good, but they were more worried about the intent of theirs than anything. Sorry about that. This card, his was a sweetheart. We thought that's all the others. I know. Really? What? He was Mike's trying to get your job. I got my own job. I'm getting busy. And you know, it's funny. I hired Tim, senior architect. Hello. Hello.
10 minutes is up. Go ahead and find your seats. If you would think about something, GAHI is a voluntary association only. We don't get paid for this. So if you're interested in learning how to get involved, please contact one of the board members. We're thinking about increasing the board a little bit, and people, if you want to get involved, it is how you get to, you get more contacts, you get more involvement, you actually get to make things happen. It's exciting, and you get to put on your resume, board member, GAHI, Georgia Association of Home Inspectors. So if you are interested, please contact one of the board members and get involved. Thanks. Michael.
Thank you. Yeah, as he said, we don't get paid for this, so ushers, which if you would, please take the place. All right, I just looked. We've been having some good discussion about this, but I've got some really fun photos at the end of this. So they took down the clock over here, so I can't see what. I don't even have a clock here. So we're going to snap along a little bit, but I hope you guys have been enjoying this so far.
Yep.
Yeah?
Yep.
Light mumbling. Okay, yeah. All right, well, let's move along. So that's that. This is a neat little pamphlet if you wanted to look this up. If any of you are looking at buying, building, inspecting, or being on the coast, this is a neat little booklet that I was doing some of this research out of. Really nice. Alternatives for high wind zones. So again, remember, we were talking about those different areas on the building, and you can see we can go from common nails to ring-shaped nails to screws. We can increase. So think about that house that had the addition. If they screwed that roof or that floor deck down, now we've increased the bracing capacity of that panel. Now wait a minute. So if we've added screws, we can increase our bracing. If we did deformed nails, we can increase our bracing. So if you've got some of those odd things as a builder, or even as we're looking at it, if they've done something more than just using common nails, well, that could bring them into compliance. We could even change our framing members. High-dense species, such as southern yellow pine, holds fasteners better than lower density, such as spruce pine. So if they used southern yellow pine for the framing, that could make a difference. Alternatives. This is the one we see all the time, hurricane clips. But we've also got these tall straps where they can use them up and around over top of trusses. Now this is something, this actually, I run into this every day, and I'm writing this up all the time during rough inspections, and the guy's going, well, we followed the truss manufacturer. Okay, so trusses have to be braced in accordance with the bracing pattern outlined in the truss package. If we've got the truss package in the permit box, hooray, we can actually look at it. How often do you find it in the truss? Yeah, they've been using it to scrape up the mud. So if they've got it, if in the code it says, with the lack of it, you use this. So take a look at this for a second. Now you got diagonal bracing. This is on the top of the truss, or the bottom part of the truss. So they've got bracing running across on the top cord, or on the top of the bottom cord.
Right.
So often we think, well, there's drywall there. Well, that's not being used as a bracing method for the truss. The bracing method is the bracing. So then we've got lateral bracing. So notice we've got a continuous lateral straight brace that runs all the way across the trusses. And on the angled cords, notice that. And then it's got vertical web diagonal bracing. So we've got a diagonal one that's on this upright. See this upright? We've got a diagonal one here and a diagonal one there. That's at those vertical cords. So those are all the requirements for bracing a truss. And I see this missing every day I go out there.
What is this source for this?
This is the SBCA Building Component Safety Information Guide. It's this book. There's the website. Snap a picture of it.
What authority is that?
These are the guys that design truss applications.
Okay.
And I just had a client come back and he said, well, the builder said that he installed the bracing in accordance with the bracing method. I said, okay, great. Have him give you that because it is based on this. So let's compare the two. I'd be surprised if there's less. So, everybody get that?
You know, back in the 90s, they used to put those little stickers to tell you where your lateral braces.
Yep. But it was only for the laterals.
Yes.
It wasn't the diagonals, or it wasn't the diagonals on the top of the cord. Because again, like I say, oops, back. Again, like I say, I mean, this is a diagonal. These red ones are diagonals going across that top to hold the. Basically, if you think about it, this is going in before the drywall. So those diagonals keep those trusses in place. So when they put the drywall on, the trusses are what? Straight. What a novel idea. But really good guide. I had a student one time give me this thing. Man, you read through it, you're going to see a lot of stuff that's, you go, woohoo. Oh, guys. So alternatives for high wind zones. This is kind of interesting. Again, just wrapping your head around, notice what they're having to do here. Strap these things down, and then they've got these stud plates. Again, to tie that roof to that top plate to the studs. And for us, all we got to do is nails, but, I mean, at least look at it. Oh, protection of openings. Oh, this is kind of interesting. So, the code actually has a guideline on protecting openings and how often we're supposed to fasten plywood over top of windows and door openings during a high wind event. So think about that for a second. So the code has in it a guideline on protecting windows during a high wind event. That's kind of interesting. Why would they do that?
Because they're idiots.
No, because when the window blows out, now we've got a new stress on the house. The wind is going into the house, and not only is it sucking on the backside, it's pushing on that wall. So if you've got wind that's blowing over top, and notice the wind's coming in, large suction here at zone, what was that? Zone 3. Some here on 2. And look, over here on 2, this is still light because the wind's coming from the other way. Suction on the backside, it blows out the window, and now we've got forces pushing on that wall. This wall's being sucked and pushed at the same time. What's going to happen to it? Potentially going to collapse. Kind of like that one. So when they do these post-disaster investigations, man, see if you can ever get any of those reports because it's really interesting. This is our industry. This is our field. Read some of this stuff. If you can get a hold of a post-disaster investigation, they'll talk about how things failed. Once you know how it fails, then you know what to look for when you go out there to look at it later. Or even like, I read a report a bunch of years ago about NFPA did a study. They said, before you tear down the house, we want it for 1 day. NFPA went nationwide with this. And they investigated houses that were all the way back into the 20s with knob and tube wiring. And they looked at the electrical system, they cut it apart, they looked at those components and looked at those things. And you know what they found? A properly installed knob and tube wiring system that had not been messed with was safe. It'll last forever. If the electrical system hasn't been messed with, and it meets the code that it was designed under, it's safe. The problem is us, people. Because you have old NM wiring, pre-19, when did the insulation change? Somebody remind me, was it 89? Pre-89? If you put insulation on it, it heats up and melts. Non-metallic wiring, pre-19, I think it's 89, 88, 89, something like that. They changed the formula for the insulation. Pre-1989, if you insulated it, it'd melt. It'd catch fire and melt. So, what are people doing with their attics? Blowing them full of insulation. You strip off a wall and you go, oh wow, look at that. This house was built in the 70s. Old wiring. Well, that's okay. We'll just put insulation around it. You're sitting there waiting for a fire. Electrical fire. Anyways, exterior masonry. So, I threw a couple other fun things in there. This is a fun one. Who's going to fix this after the fact? So, Brick Institute says masonry veneer, well actually, let's go back to the code. Code says, in 703, it says, all masonry veneers shall be installed in accordance with this code and the manufacturer's instructions. Figure 703 shows this picture roughly, has a brick windowsill. It does not have the degrees on the slope of the windowsill. So what's the slope of the windowsill? Well, we go back to the manufacturer, the Brick Institute. Slope of the windowsill is supposed to be 15 degrees. If you put a protractor on the one that's on the code book, extended the lines up, it's 15 degrees. They show it, but they don't tell you what it is. This tells you what it is. They also say you got to have flashing. Now, anybody see a problem with this piece of flashing?
There it is.
What's that? Speak up.
We know it's there.
You're absolutely correct. That's the name of it. Through wall flashing. It's supposed to be like this. But there's actually a code violation here.
No end dam?
Exactly. No end dam. Every piece of flashing is supposed to be end dammed 2 inches. Recommended 1 inch required. They never do it. So that through wall flashing, the water goes through the brick. Why? Because brick is porous. Of course it's going to go through it. Goes through the brick, runs down the back side of the brick, hits the flashing, and it runs out either side of the flashing and down into the wall. Well, isn't it supposed to follow the weave poles? Well, it could, if they're in the right spot. So, here's another one. How many times do you see through wall flashing at a rake or along a roof line? How many times? Anybody? No? Yeah, no. You see some step flashing there, maybe. Oh, the flashing's behind the brick. Oh, great, so how's the water getting back out? If it's behind the brick, how's the water getting through, back to the roof surface? You know, they've even got pre-manufactured inside corner end dams. So, something. Now, again, I mean, if we're really, you can freak a person out from ever buying a house. Do we really get off into actual end dam application for clients? Probably not, because we can't see it. It's not there. But I want to instill this knowledge in you guys, because this is what we're supposed to be seeing. Some sort of flashing at a rake ledge. You know, and notice this one. This one, no end dam, because it can go into this one, no end dam. And then the last one, it's got end dams. Ah. Underneath doors and windows, end dams. If you happen to be there when the guy is installing it, look for it. Because every once in a while we are, right? Everybody's seen a mason put them in it. Adhered masonry veneer installation. Where is that supposed to be installed? In grade, at grade, or above grade?
Above grade.
Above grade. Flashing at foundation. Yeah, look, here's one. That's wrong. Manufacturer does not say that this is okay. And in accordance with 703.12,
Shouldn't that be a weep screen?
very good. Yeah, see? 26 gauge galvanized or plastic with a minimum vertical flange, attachment flange. It's called the weep screen. Stucco, same deal. This is hard coat. Oh, it's hard coat. We don't have to worry about that. No. Of course you got to worry about it. There you go. Foundation weep screen. 2 inches minimum at paving, 4 inches at grade. Nobody wants to see that. Did you ask them? Did you ask them, do they want to see that, or do they want to run the risk of having capillary action water get whipped up into their wall assembly and rotting out their sheathing? Did you ask them that? Ask them that question. Then I'll go along with you. So yeah, you can see here on our stucco over here, we've got our metal lath, we've got our weep screed, again, 2 inches and 4. I see this all the time. Landmark stone. This is an adhered stone veneer product. There it is, right there in their instructions. The manufacturers are saying, don't put it down into the dirt. Here's another one. Well, there's the stone application, and here's stucco. Nobody's going to notice that little strip of foundation there. Yes, sir.
One thing, jump back real quick. That 2 and 4 inch.
Yeah.
That's.
What's that?
It's on the IRC.
Oh, yeah. Yep. You're absolutely right.
It's on the installation instructions too with the material.
It is. That came right out of Landmark stone. Ventilation. So they actually are changing this coming up, and I'm not sure I wholeheartedly agree. And Sandy spoke on this the other day too. But so mechanical ventilation. So they've actually got air changes per hour, and they've actually added a table in there where we have less than 5 air changes per hour. We have to have a whole house mechanical ventilation system in accordance with our mechanical section. That's what they're talking about. That's a whole house mechanical ventilation system. It's not this little inline duct, but we see that a lot. I mean, it's okay. This is better because it's bringing the fresh air in, bypassing it with the exhausted warm outside air. You're getting that heat transfer there, and then the stale air is getting pushed out and the fresh air is getting pushed in. That's already conditioned, preconditioned. Nice system. So that's giving you fresh air to a building.
Doesn't the code allow that though, the single duct from the outside to come in the return air?
Yeah, I think I got it.
You just have to be able to control it, to override it, right?
Well,
It should have a damper on it, shouldn't it?
yeah, and it's supposed to be continuous.
So it's not that.
Your furnace doesn't run continuous.
Well, the newer ones do. You know, they have the option, the circulation.
It's an option.
Yeah.
If you set it on circulate mode, it'll run continuous. But and if it's run intermittently, the fan has to be bigger.
Yeah.
So 25% for each 4-hour segment. So there's the table. So I mean, if you think about it, number of bedrooms, 2 to 3 bedrooms on a 2,000 square foot house, 60 CFMs. So that's basically a bathroom fan. Bathroom fans are 50. Little boost. Well, you could have 75 is a commercial bathroom fan. So, you know, that's basically what they're looking for supplying fresh air to the house. Here's an intermittent for runtime for each 4-hour segment. Is it running 25% of the time, 30%, 50%? So how many fans do you need if you run 50%? Basically 2. So if that furnace, So what are we seeing? 90% of the time, what are we looking at? We're seeing one of those things. You're seeing one, and it goes from, usually the attic one is the one I see, because they run it over to the roof and vent it out through the soffit.
If you're lucky.
If you're lucky. But if it's not continuously run, we gotta have 2. Or maybe 4 if it's only running 25% of the time for each 4-hour segment. And then it's a question for the HVAC guy. Anyway, so this one actually, this illustration, I thought it was funny because I found it, but it's actually in the wrong spot. This is supposed to be on the return, not the supply side. It's supposed to be on the return side. They actually showed it in the wrong duct, but oh well. It gives us an idea of what we're seeing. It's illustrative purposes only. Gosh darn it. Decks. So I grabbed this because this is a couple of you remember this one? This nightmare that we had? Adding the washers between the ledger board and the house? Oh, God. So this is a deck attachment. This is one that came out of the coastal application that I really like. If I was putting a deck on, I would be doing it like that today. You notice they put a piece of Z-flashing at the bottom with ice and water shield over the top of it. They attached their deck board to it. Then they put a piece of flashing on top of that and put ice and water shield over top of that. What a nice system. That's not going to leak. What's that?
You never see it.
No, but if it was me putting that on my house, I'd do it like that. And I mean, you know, I would think any of you would want to probably do something similar. I really liked it. Sometimes you run across these quirky little things as you're doing your research.
Can I ask you a dumb question? The bottom Z flashing, why do you need that in addition to the top? Like at the top, it keeps the water out, but that bottom, the one that they're describing there, the third one down.
I'll give you a dumb answer. Because it's there. No. Because we've got siding. You got your siding. What is your siding product?
Oh, it's protecting the siding.
Yeah, it's stopping that water from getting behind that siding, whether it's stucco or hardy plank or whatever. But it gets that water out to that face.
So it's less about the deck at that point, it's more about what's below it.
Right. Yep.
I missed the washer thing before. Could you?
Oh, this nightmare?
Yeah.
So what the code was requiring for a little while is your ledger board had to be spaced.
Sure.
There had to be flashing, and then you had to have washers holding the ledger board off the structure. Was it 3/4 of an inch or an inch? 3/4. It had to be off the structure, and they were using these spacers. They're almost like
So that's gone now?
Yeah, I mean, nobody does that. It's a pain in the butt to do because you got to line all that up with your bolting pattern. You got to do your bolting ahead of time.
Plus you're
Before you put your
weighing
thing
the
on.
ball
Yeah.
too.
Yeah, I mean, then you got that break. I mean, it's just a nightmare. So I never liked it, but what they were wanting there for a while. So I grabbed this picture because I thought there was an interesting thing, a topic here to talk about. We're talking about how buildings fail. And so often we see these little additions that get thrown onto houses, and we see issues with them. Well, why? Why did they happen? Or what's going on with it? And what does the code require? So I thought this was kind of an interesting little topic, and I kind of added this to the presentation last night because again I thought it was an interesting thing that we could talk about. So there's a bunch of components here that we're all kind of familiar with, but let's just break this down a little bit, and let's take Jimmy Joe Bob's addition that he did down the road. So we got our 2 walls, we've got our rafters, and we've got a ridge board. That's a 3/4 inch board at the ridge. It's not a beam, it's a board. So ridge boards, we can offset our rafters 1.5 inches so that we can end nail through the ridge board into the end of the rafter. Great. Okay. So that's what he did. Built an addition. we've got downward pressure on those rafters, which also creates outward pressure on the walls. Now, as I mentioned earlier, in my past life, I was a contractor. I worked for a guy that built this addition. We went out, and these walls were splaying out, and this whole thing was sagging. The client was not happy. So the guy I was working for, he looked at me and he went, "Can you fix it?" And I thought about it for a minute, and I said, "Well, yeah, but I don't know if Marty's going to be happy." And so we talked to Marty, who was the homeowner, and we said, "Marty, I'm going to have to run some things across here in order to bring this thing together. And I'll make them into a beam, so it just looks like a beam for you. It won't be like a ceiling joist, it won't be a ceiling, it'll be just a box beam." And he went, "Well, if that's what we got to have, that's what we got to have." I liked it. So what we ended up doing is wrapping steel cable around both of these top plates, and I put a come-along in the middle and pulled this house back together, pulled it back up. Then I replaced the come-along with turnbuckles. We did 3 turnbuckles down through this thing. And once we got the turnbuckles in place, I scored the threads so that they couldn't unwind, and then built box beams around it. That's what we did to hold this thing back together. So, it's real life. This happens. So, that's basically what I did. Now, in the code, we can add ceiling joists. We can have ceiling joists here. We can have ceiling joists there. We can go up how much? Does anybody remember?
1/3. 1/3.
1/3, absolutely. So if we do that, the connection requirements, do you realize that there's more nails that are required when you go up 1/3 than when you're down, than when you're down there? Typical example, if someone had brought their code book, we could have done a little example, but you're looking at 4 or 5 nails in here on a standard application, maybe 3 to, in our zone, it's probably 3 to 5 nails. Oops, if you move it up, if you go up 1/3, look, how many more? 50% more. So that's 4 to 8 nails. So there's more fastening that is required there, and your rafter span gets reduced. Look at that. You multiply it by 67% if you move it up 1/3. So, if you've got a rafter that could span 14 feet in this application, in this application it might be only 10. Because, almost a 67, almost a 40% reduction, nearly 40% reduction. You're going to go from 14 to about 10. So doing this is great because we add to our ceiling height and so forth, but we also reduce our rafter span. So that could be a big factor in your rafters, the size of your rafters. So going back to our little building here, framing details, ridge boards. So we got to fasten our ridge board in accordance with our fastening table, 602. There's also, let's see, this is where the roof pitch is less than 3 and 12. The ridge has to be designed as a beam. So, and it's got not less than the depth of the ridge board is not to be less than the depth of the cut edge of the rafter. When I took the contractor exam, that was one of the questions they asked. What was the length of that based on the slope of the roof? I skipped that question. It's like, that's too much math. But here we've got an example of one. So you can see here, is that roof supported? No, got to add something. They added 2x2. Okay. Now, notice this ridge is a beam. Do we have to have ceiling joists over this, in this ceiling?
No.
Nope. No, we don't. Because the beam is supporting everything. Now it's all just sitting up and pushing against the beam. That's a, I can't really quite tell. I think it's an LVL, triple LVL. I mean, that thing's not going to sag. Those rafters going up there, they're just resting against it. No ceiling joists are necessary. All as long as our walls are nice and straight and tied together properly. Probably not a single top plate on that, but. And then where the roof is less than 3 and 12, it has to be a beam. So there you go. And now this one doesn't have to be a beam. They just opted to not have ceiling joists. And they just constructed it as a beam. But if you've got a single ridge board up there, you know, either way, you still have to provide some backing for those cut edges of those rafters. Ceiling and joist connections, according to our fastening table, see 60231, there's our fastening table, nail it. I think for a typical rafter it's 3 16-penny nails, base nail, or toenail, where they meet over interior partitions, they're nailed to adjacent rafters. Yep. Where they're not connected to the rafters. Now, if our ceiling joists aren't connected to the rafters, now we have to have rafter ties. They almost look like ceiling joists, but they're not tied to anything. They're tying that roof rafter into the structure so it doesn't want to splay out. Where they're not provided, the ridge formed, again, supported by a wall or girder, designed in accordance with accepted engineering practice. So, again, with those, you're dealing with such a long span, you're not going to get those kind of spans out of conventional lumber. It's going to end up having to be engineered. Collar ties. We're all familiar with collar ties. Collar ties are in the upper third, 4 feet on center. They can be down to a 1x4. And they're resisting wind uplift. So if you remember back to that illustration I showed you where we had negative pressure outside, we got higher pressure inside, these are resisting that ridge from getting lifted up, that roof from getting pulled up. They're helping tie those rafters down, tie them back together to each other. We can do collar ties. So you can see our collar tie here. But you know, I thought it was interesting to note that there's an illustration right here. Do you know, anybody know what that is? In the code book, they don't tell you what it is, but they show you. They show you a picture of it. Anybody know what that is?
Strap?
It's a strap, exactly. Straps. So what it is it's a strap that goes from one rafter over the ridge to the next rafter. It works in lieu of collar ties. You can have it. I think the application is they're supposed to be 4 feet on center. Is that right? Still? I think they're supposed to be. I don't.
It depends on the wind load and all that.
Okay.
Until you go by the manufacturer.
Yeah, I mean, it's something like that. Now, for the most part, what are we seeing? If we're going out there after the fact and doing an inspection, we're inside of here looking up. That's on the top of the rafter. There's sheathing on top of it. You ain't never going to see those. Unless you got up into the rafters and you looked and you could probably see the space where it created between the sheathing and the rafter. You might be able to see that. But for the most part, we're not going to see them unless we're working with somebody as it's being built, which is a possibility as well. Oh, LVLs. LVL fastening. You know, I grabbed this right out of Georgia Pacific's guideline for LVL applications. So it comes straight from the manufacturer. You can see if we've got 2, we've got nails, what is it, 3 rows, 12 inches on center, or 4 rows, 12 inches on center, 10 penny nails, 16 penny nails, 2 rows or 3 rows, 12 inches on center. So if we've got nails, we're doing it about 12 inches on center. From one side. Doesn't have to be nails from both sides, because the nails go through one of them. If it's 3, now we've got to have them on both sides. Now, I had a client ask me while we were out there, he said, well, what if it's not nailed from both sides? Is that big of a deal? I said, well, one of the things that you got to think about, and I tried to find someone that had talked about this, but I could, or had a picture of this. I found a lot of people talking about it, but nobody had a picture of it. So what can happen is, let me put this in. If you've got 3 and they're side loaded, this member can be pulled down out of plane with the other 2 members. They're not working as one. It's an individual member that's being moved. So that's side loading. Top loading, they can actually splay apart. And if you look at some of these big houses that have 3 or 4 LVLs put together that aren't bolted, you'll see them, they're opening up. Because that pressure is just pushing them apart. They're not acting as a single member. They're acting as 3 or 4 individual members that are starting to move independently. And that's one of the failure points that you're getting. And then people go, well, why do I have cracks in my drywall? Well, this is why. Because you're getting that movement in those beams. So, you know, they've got allowances for nails, 1/2-inch through bolts, the SDS screws, which we see a lot of. Truss lock screws, they've actually put it right into their instructions because they recognize that they are out there. So, fun stuff, huh?
The 4-ply, does
Yeah.
it have any, get the bolted?
So 4-ply, you can see that there's no nailing allowance. This one, you can do 2 rows, 24 inches on center with bolts, or you can do 24 inches on center, 2 rows of SDS screws, or the 6 3/4 inch truss lock. That's the only thing, you can't nail it. Nails just aren't effective.
And I guess the common sense thing to be would, if you see LVL separating, regardless of the nailing pattern,
There's probably something wrong.
something's going on.
Yeah. And also look at the bottom of it, because if you see that one that's got all the joist hangers on it get pulled out of plane with the other ones, well, they don't build it out of plane to begin with. You know, that one's getting moved. So. And then when they're fastened from both sides, notice the stagger. They're supposed to be staggered. So you've got nails on this side, 12 inches on center. On the other side, they're 12 inches on center, but they're staggered halfway. So they don't want the nails to run into each other. I guess. It just makes it stronger. It's a better tie. See, I told you I had some fun pictures. I should have run the presentation backwards, but I wanted to get away from these. What failed?
An extra windmill they put in the basement.
Yeah, overlooking the carport, right?
There you go.
But yeah, I mean, shear wall bracing. Inadequate shear wall bracing at the garage. Damn it, we didn't get the plywood up quick enough.
Yeah.
Eileen built that.
Yeah. Yep. But you can see how important that plywood is, or that OSB is. And you know, I mean, even look at this one. See, they didn't run this all the way out for a portal opening.
So
That's bound to fail anyway. What's that?
Is that acceptable deflection?
Yeah, right? There you go. Oh, look. I don't know if you guys can see that, but anchor bolts, 2-inch washers. He's actually got them. Adding in his plywood, nailing pattern, 3 inches on center, up the sides on both studs, and then 3-inch box pattern on the header.
I feel like a lot of times they miss the top, I guess it would be the plate over the header.
Yeah.
You never see that.
Yeah, and you know, the other thing I run into a lot is when I go out, they've already got the house wrapped with house wrap.
Yep.
But if you run your fingers along there, you can feel where the nails are because they didn't set the pressure on their gun right, and it's shooting through the face of that OSB, and you can feel where all those nails are. So you could actually pick on them a little bit if you wanted to, but otherwise you just say, well, it was obstructed, I couldn't see it. Here's another one that failed. What do you think failed on this?
Context.
Single family.
This is the end wall.
Looks like the top plate connections on loose.
Top plate connections and corner studs. Corner studs weren't nailed. Anybody look at nailing pattern on corner studs? Know what nailing pattern on corner studs is? 16 penny nails nailed 24 inches on center. So usually when I go out and look at them, I see them here, 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 and here. No one's got the ladder to get those up there. So the top isn't nailed. Or oftentimes it's just the middle. Stud packs. Anybody know what a stud, you know what a stud pack is, where you got 3 or 4 studs holding up a bearing point for truss or LVL or something. Stud packs. Nailing pattern on a stud pack. Anybody? Same as a corner. 24 inches on center. You know what I usually see? Nails on one side. The other side's not nailed. Then you take this, then you stand there with your client and you go, look at this. You take the stud and you pull it away a little bit and you go, wow, look at that. It's going to hold nothing. It'll just move. So yeah. Look at that house. Now, I think, if I remember right, I think this was a victim of microburst. Have you guys heard of those, microbursts?
Yep.
Sudden downward pressure, atmospheric pressure. This house collapsed because, I think it was this one. I have a couple of pictures of those. But it was a collapse because of a microburst pushing down on that house, and it just blew out. Now, can we design for that? Probably not. But to somebody's point earlier, I mean, if we're not even meeting what we're required to do today, are we going to be able to resist something like this? You know, it's like I said to one of the guys, I said, if you're not even able to meet the energy code that's in existence today, how are you going to meet the one that's coming in for tomorrow? I mean, you gotta catch up at some point. Hey, there's one. Yeah. Now, I will say, I see some bracing missing. There's no diagonal bracing in here, which would have been tying this wall in. There's no bracing here. That would have been tying this wall in. There's no bracing here, here, or here. All the bracing's missing. And all of that bracing that would have been coming over to that wall would have been tying that wall in. And you would have had probably an angled piece running along it that everything would have been nailed to help hold that up. That's why that failed. We talked about bracing. Now, decks. Everybody loves talking about decks. We've had some classes on decks, good information about them. I was actually in a lawsuit here recently about a deck collapse. And the opposing counsel said to me, he said, well, the deck was 30 years old. I mean, let me lay the groundwork for you. So it was a 30-year-old deck. It was built in the mid-'80s. It was nailed with those 24 penny nails, those spikes, those big heavy spikes they used to use in the 80s. There were no anchor bolts. Someone came out and did some light repair, changed some deck boards, and they anchored the other end where there was nothing but nails, 16 penny nails on it. So they ran some screws into that to fasten it in. But there was, on this main part of the deck, it was only these 24 penny spikes. So he says to me, should they have added flags, or should they have added lag bolts or through bolts into this deck to improve safety? Well, they could have. Well, wouldn't there be a code that would say that they have to? No. He's like, you mean to tell me there's no code that says they have to put bolts in this deck? Not until they replace it. And I said, furthermore, if you look at your picture that you just handed me, the 24 penny nail did not fail. What are you talking about? The deck collapsed. The wood failed. The fastener is still in the wall. And he looked at it and he went, huh. I said, so if we add more fasteners, the fasteners aren't failing. It's the wood that's failing. It was old. We got to expect that. It needs to be replaced. He said, well, it was rotted out on the back side. Nobody could have seen that because it's on the back side between the house and the deck. Nobody's got x-ray vision to see that. He's like, well, shouldn't the guy that was doing the repairs on the deck, shouldn't he have seen that? I said, how? He's human. I don't believe he's Superman. Superman could have seen it, but a regular human being can't. You can't physically see behind wood. So the wood failed, fastener didn't. So this one, on the other hand, this one, it looks like everything failed because it pulled it off, the whole thing off, and everything came down. So we want to always make sure we look at decks, you know, to that point. Always look at that connection point. If they've got spikes in them, you know, we would probably recommend that we add something, but, you know, what do they add? Well, that's up to the contractor what he wants to add. If it's a finished basement, they're not going to be putting through bolts in. They're going to probably try to put lags.
Make it freestanding.
Yeah, make it freestanding.
That's the simplest solution.
You brought up true lines earlier.
Yeah.
Familiar with that argument that we're allowing true lines at one, or truss lines at one point, and now we're not? They were trying to use them instead of the through bolts on the electrical board.
It's interesting you'd ask me that. I actually got called from a manufacturer to talk about those. And they were having trouble having them meet the shear or the pull-through requirements that a through bolt will make. They'll get close, but they're not the same.
I tell people, they're like, these things are allowed. I'm like, no, it's not. And I tell them also the picture you showed earlier with the nut on the inside. You're not allowed to have the nut on the inside. The nut's got to be on the outside where you can check it and see if it's tight.
Yeah.
With the
Yeah.
truss lock, you can't tell what they're into.
And you know what? I just did a house, 2-year-old house. Their bolting pattern, they had one bolt kind of sticking out. Oh, they got missed one. When I got down into the crawl space, guess how many of them had nuts? None of them. They forgot to put nuts on. Yeah.
You know, looking at this, I think probably one of the most common elements of what you said was absolutely correct. It probably wasn't flashed.
No.
And basically its failure was from moisture getting to the inside. Now, depending upon how that basement is done on that house, I mean, if you've got a drop ceiling, you might be able to look up inside there and look on the band board. If it's a finished ceiling, you can't. But, you know, just looking at possibly the age of the house, the consideration would be there's no flashing there and it's rotted from the inside.
That's right. And you know, I mean, it's interesting. I did a house like this one time that had, this was stucco. It was ephes. And when I went out there, he'd already taken the deck off. And the band was completely rotted out. I mean, it was gone. And we went inside, and I'm looking at the wall inside. It was unfinished basement. There was mold up on this. It looked like mothra. I mean, it covered this whole wall. It looked like this huge butterfly of mold on the side of this basement wall. And I said to him, I said, "You haven't noticed this before?" He goes, "Well, I travel a lot." You must travel an awful lot. Yeah, I mean, and then we went up into his living room, and at the trim board, the floor dipped about 1.5 inches. He said, "What do you think I should do?" I said, "I think the first thing you should do is get all your furniture off this thing." But I mean, it had rotted out that wall so bad. I should have tried to find that for you. That would have been, but it rotted out that wall so bad that the plates were collapsing and the floor was sagging down and pulling, you know, everything with it. The contractor that came out jacked the floor up, tore out the entire wall, and ended up rebuilding the whole thing. And when he did, he found, because I actually kind of half stayed in contact with this guy. He was calling me about questions periodically through the course of the project. The contractor found that there were no anchor bolts in the floor at all. So they went back through and put red heads in. And then when they straightened out the floor again, all the flooring came loose and they had to tear all the flooring up and redo all of it. And with that, you know, that comes with base plates and shoe molding and all that. But yeah, I mean, he had his big couch sitting there. I was like, man, the first thing you gotta do is get everything off this floor. This is crazy. So, yeah. Trusses. We want bracing. We want these things braced. This one didn't last. They had it up there. It fell over. So, this, how many of you ever checked out NFPA's website? Anybody ever gone to? Pretty cool stuff on there. Did you see this video? This video? So what they did is they built an I-joist floor. And then they built a fire underneath it. They put these two mannequins in there with 300 pounds of gear on them. Because the average firefighter loaded up with gear is about 300 pounds. They put them on this floor and they built this fire underneath it. Now, notice how much deflection is in that floor with 600 pounds of gear sitting in the middle of it. Now, one of the things they found was as the fire was starting to really get going, that floor would raise up and then it would drop back down. It would almost breathe. And the deflection in it was somewhere around 3 or 4 inches, up to 5 inches in some spots, because of this movement. So if you've got 5 inches of deflection, try to walk across that. Their point was their firefighters are going to have trouble getting across an I-joist floor during a fire condition underneath. So what does the code, some of you guys have taken the next year's classes already, what does the code require on the bottom side of I-joists now? Well, next year. Drywall. Why? Because of this video right here, this test. When they got all done, they took it apart, and this is what they found. The inner web burns out. The two top pieces, the top and bottom piece, they stay somewhat intact. But
You're saying when we're looking next year,
unless they write an amendment. Now, you sat on the, did they write an amendment for that?
No.
Yeah, so yes, new construction, those will be covered with drywall. And if it's a crawl space with mechanical equipment, it's got to have drywall.
But if they're finishing the ceiling,
That's what they
How you gonna verify insulation in the floor?
Yeah, okay, drywall's cheap. Here we're using it as fire protection. We're trying to protect these trusses, these I-joists rather. Because one of the conditions is that I-joist will burn out. If you use conventional lumber, you don't have to do that. Conventional lumber burns slowly. So if you've got an I-joist sitting there that's just getting riddled with fire, well, we want to try to protect that and give the firefighters time to get in and fight the fire and people to get out in the event of a fire.
Yeah, Mike, thinking about that, I think that was deleted.
Are they looking at deleting it?
I think they're deleting it for Georgia.
even in the crawl space.
Well, in a crawl space, for the most logical reason, I mean, builders today, in this area, obviously, you're not building on crawl spaces. But, you know, in other areas, they could very well be. But I believe now, just thinking back on it, that was deleted about the drywall material to the underside of engineered truss systems.
That's a terrible decision, but I'm not on the board, so my opinion doesn't matter. Yep, right here. And like I said, until they come out with the final amendments, we won't really know. But
They're putting insulation in that floor system now, even on unfinished basements and crawl spaces. That would change that.
not really, not by much. Because if you think about it, where's the insulation got to be?
It's supposed to be up high.
All the way up against the underside of the floor deck. So the insulation, the most, will come down to about maybe here, because our 19 is 6 inches, these are 19. So it's only covering about half of it.
Right.
I think on the DCA website, I think you might be able to go in and see if the proposed amendments and check that out. But that does seem familiar to me that it was deleted.
Yeah. Yeah, that would be a terrible decision, I think. But again, that's my opinion.
Basements wouldn't be a big issue, but crawl spaces becomes a bigger issue.
Yeah, yeah. I mean, crawl spaces I can kind of almost see. Now, I think one of you guys, I think the one that's not paying attention there, looking at his phone. Hank, didn't you have the picture of the kitchen floor where the marble was rolling over to the island?
I did have some pictures where I use a marble to roll it over to the island.
Yeah, because here's one of the issues with I-joists is they do have a built-in deflection. And you put, well, how much is a piece of granite on an island? 500 pounds? Yeah, it'll sink down a little bit. And then people later on complain when they're walking through, the pans and stuff inside the island rattle. Why? Because you're on a trampoline. I mean,
How do you tile that floor without cracking the tile?
good question. That's a good question. How well will it last? Yeah, well, I see a lot of them are just wood. But yeah, I mean, you know, if you've got that I-joist already under tension with an island, and it's already being deflected some, bowing it down, well, it's going to rattle. Now, some of the builders have taken it a step further, and they've doubled up the I-joist there. I've seen some of them where they'll run 3/4 inch plywood on both sides of the I-joists to help stop some of that movement. And that could be a mitigation thing. If you're consulting with a client, that could be something that you could suggest. Hey, you know, if you're trying to get rid of, we're not trying to design anything, but if we're trying to give them some solutions, hey, if you put plywood on either side of the I-joist, it's going to stiffen it up. You'll stop some of that movement. Now you'll end up building that deflection into it. But, yeah.
Don't most of them, the national builders, and the truss suppliers, they provide 3 levels of deflection allowable. They have different levels, and what are most of them going to do? Most of the nationals are going to...
They're going to go to the minimum.
The minimum.
Yep. And I actually went into one where the woman brought in, she had one of those tall hutches, and when she put that up against the wall, it leaned forward because of the deflection that was already built into the floor. And she was afraid it was going to fall over. So she ended up adding 3/4 inch shims to push it back against the wall. So, I mean, you know, new construction materials, there's a lot of nice things about them. You can get huge spans and so forth, but there's also some things to consider about the deflection that's built into them or the issues. I mean, a lot of us are dealing with mold. On an old house, you don't deal with, I mean, mold is less of a concern in some of the older materials than some of the newer materials. These I-joists or the MDF, oh man, that stuff is horrible for mold. But, you know, there you have it. Unintended consequences, right? So, fire conditions. You can see what the truss plates do. They swell up off of the wood. I know one fire department over on the west side of Atlanta, they won't go into a house that's built with trusses. They make notes. These houses are built with trusses, these are not, or whatever. They won't go into them because in a fire condition, those plates heat up and they separate from the trusses, and then it's just angle cut boards being held together by friction. So they walk out onto those things and they collapse. They drop down. Yes, sir.
In looking at the DCA proposed amendments,
Yes.
it says delete section 302.13, fire protection of floors without substitution. I don't know.
Yeah. Thank
That's
you.
the proposed.
So I mean, that is going to be deleted. So that's not a good decision, I don't think. I mean, it's not certainly going to help our fire department. Or if you're on a volunteer fire department, it's not going to provide any protection for you either.
That's the way the picture is that thick lumber really doesn't burn.
Yeah.
That's why heavy timber.
Yep. Yep.
I don't know, it's charred, but it's not really.
Yeah. Yeah, and that's a good point. I mean, you know.
What about open truss? As opposed to these are I-beams.
No, this is truss.
So that's an open truss there?
Yeah. Yeah, and what he was saying is, you know, the lumber itself, there's some integrity left to it.
Sure.
It's badly charred, but there's some integrity left to it. But these
So the
plates,
gusset-
they're separating, and the part that gets charred with the plates.
The gusset plate is then becomes the issue here.
Right. Yep. What's holding it together? Glue? Prayer? I don't know. Not much. Here's a plate that failed. This was an angle plate that they put on a beam. It's not a support, under support. It actually stayed on the beam, but it pulled out of the lumber. Too short a nail. Fastener was too short. And that's something, as an inspector, I mean, even on the municipal side, we can't see the length of them. You know, you look at that and it looks like they're good, but you can't see the length of them unless you take them out. I thought this was kind of an interesting picture. This is a picture after the hurricane. Have you seen anything missing?
The house.
All right, let me rephrase that. But boom. I'm going to keep. You're going to come to all my classes. So yes, the house is missing. You see anything else that could have prevented the house?
Sill plate.
Sill plate tied out.
Yeah. Yeah. There's no anchor bolts. None. Now, it does look like, and I tried to blow this up to try to see, but it does look like there's a strap there that might have been pulled through. But it doesn't. Yeah. Because they didn't have the ties to the plate.
There's more than 30,000 homes down there to do all this thing, so we're framing it, they have to be down there. Into the flat out. So then company pushing it all the way up through and across, shut down. Coming through the neighborhood, everybody just built.
Yeah. Yeah.
The houses around them.
Gone, yeah. And you know, it's interesting. I actually did an inspection on a daycare that was being built in Smyrna. One of the councilmen, his wife went into the daycare business, and they were building daycares, and he was doing just that. He was running all thread from the foundation through nutting down each floor system and top plate, and then coupling them together and running all the way up. And I looked at it and I said to him, I said, "Why are you doing this?" He said, "Because it's a daycare." And I want this thing to stay here and these kids to be safe.
Good man.
Yeah, I mean, I was really impressed. You know, he's, you know, if something happens, he goes, I want this place to be here. And what better time to do it than when you're building it? It's open. Simpson straps. See a problem? We talked about this a little bit earlier.
Carefully installed on.
Yes, they are installed incorrectly. So, Simpson straps, if, let's see, did I do, no. So these straps are supposed to be installed in the concrete, spread out 3 inches, and the concrete is supposed to be up to that 3-inch mark. So that when you set the plate down, it sits down between them and then you wrap the things over. When you wrap those blades over, the 2 points should come together like this, or pretty close. If you see them wrapped and they cross the top, they're installed like this and they're wrong. So, and that goes back to that picture I showed you of the house that I was doing. I found one of them installed in the doorway, and I said to the guy, I said, well, if one of them's installed incorrectly, then I'm going to assume they all are, because nobody installs one wrong and the rest of them correct. So, Simpson actually says that this application, they won't warranty them. Because one of the things that the framer does, the first thing he does is he spreads them out and he hits them with his hammer. And he breaks them. Then they set the plate down and they wrap them over the plate and they nail them. So what's left? Well, it's strapped, but it's just a strap around the plate. It's broke underneath. And it doesn't provide the uplift resistance that is required.
Is that a brick foundation? Is that a brick foundation?
Solid masonry?
Yeah, that one is.
And
Unusual.
It looks like the masonry is filling in all of the holes in the brick. And then that's attached to the brick. That's, even the foundation is questionable, I would say.
Yeah, this one looks like they stuck it down through the core.
Right.
And I mean,
So that's not gonna hold it.
yeah. Those straps really shouldn't have been used on that type of a foundation at all to begin with. And the other point is, you know, when they're set like that, they're wrong. So oftentimes I'll be out looking at a house in rough and go, man, I think those are wrong. They look wrong. The straps are coming all the way over. They're touching the opposite sides of the plate. I don't think those are right. Yep, that one's wrong too. Looking at the next block. So, you know, if that one's wrong, chances are, you know, if this one looks wrong and that one's wrong, chances are they are wrong. And I had a chance to talk to one of the Simpson reps. And I said to him, I said, man, why don't you do a training class on this? Tell people how to use your product. He goes, you know how many classes I give a year? I give one every week. We teach them, and there's such a high turnover, the next guys, they don't know. He said, I just can't keep up with the turnover in concrete. So, again, now,
What code reference do you use for that, or you just use Simpson?
I go back to the Simpson manufacturers. Now, in 4031 maybe? No, that's too early. 404, somewhere right in 4, it talks about foundation anchors. And you can use alternate methods in accordance with the manufacturer's specifications. And that's where, so now the code just drew the manufacturer's instructions in, now it's code, right? As I just said, in accordance with the manufacturer's instructions. So now the manufacturer's instructions are code. So the manufacturer's instructions are that these are supposed to be spread 3 inches wide before they're set into the concrete. 32 inches uncentered.
Who is responsible for setting it? The concrete guy?
Pardon me?
The foundation contractor is the one that's supposed to.
Yeah, the concrete guy. Yep.
That has to be done when they're placing it, doesn't it? I mean, it has to be fresh.
Yeah, and usually if you watch these guys, they'll open up the box and they'll walk around, they'll go. That's how they're putting them in.
Yep.
And they're not 6 feet apart.
No, they're not 6 feet apart. They're 32 inches uncentered.
You know, Simpson should really figure out a way to make that anchor where it's already spread for 2x4
They do.
application, 2x6
They
application.
do, but they don't buy them because they're more expensive.
There's an added cost.
Again, my point, every one of them needs to be
Yeah.
already spread.
Now, there is actually a way to make this legal.
They use the wrong size to begin with.
I gotta give credit where credit's due. Simpson did say you can do this under one condition. Exactly. You drill a hole through the plate, set it down on there, and you tee them over and you nail them on the top side like that. That is approved. You can do it that way. So, you do have an option. But so often, you know, the guy that's framing it isn't thinking about that. He doesn't have a drill, he has a hammer. Yes, sir.
What do you say when you see straps, anchor bolts, power shots, and cut nails?
Well, all right, so let's work backwards from that. Cut nails are nothing.
Right.
Cut nails are 2 inches long, 2 to 2.5 inches. Cut nails hold the plate in place while you're doing whatever it is you're doing. It's only going into the concrete about 1 inch at best, so they're really nothing. Power actuated fasteners or shot nails. Power actuated fasteners, you have to go back to the ESR report in order to see what they were approved for foundation anchorage. If you look at the ESR report, and it has changed. The previous one said 6 inches from the end of the plate, 10 inches from the end of the plate, the first 2. Then after that, every 16 inches after that. That is the only way that they are approved for foundation anchorage. The new one says, I think it says 10 inches from the end of the plate. They took out the 6th one. 10 inches from the end of the plate, and then every 16 inches after that. You can't mix and match. Shot nails have been approved for this. Anchor bolts have been approved for 6 foot on center. And these have been approved for 32 inches on center when used in lieu of anchor bolts placed 6 feet on center. So, take a look at that ESR report. Like I say, they changed. And I think I saw the new one took out that extra nail that was at the end. But interior load-bearing walls. We talked about interior shear walls. I know I'm digressing a little bit, but interior load-bearing walls in a basement. Why don't let me build up first? You can answer, but let me build. So, interior load-bearing walls, they have to be fastened down. And like he said, they can use this method or they can use any other approved method of fastening. And quite often I see shot nails, power actuated fasteners.
How do you know that they're the proper shot?
And again, I'm seeing them, how far apart you seeing them? 4 feet on center. Well, that ain't doing nothing. That's decorative at that point.
Hey, Myers.
Yes, sir.
This is one of my pet jokes.
They said it needs to be 16 on the
I'll
center.
go in and right now,
The shot
cut
nails.
nails or something, you know, an interior load bearing wall, I'm like, you can't do that. They said, well, they're approved. I said, no, they're not. No, I know they're approved. I said, did I approve them? Because that's what the definition in the building code is. Approved means that which is acceptable to the building official.
Right. Now, sometimes we as independent inspectors don't know what was approved by the building official. We can only go by the recipe book. But something like that, I mean, I don't think there's a building official in town, I mean, I don't know of one, that would approve cut nails as a foundation anchor.
They're used everywhere.
Yeah.
They're used, but again, I mean, if you think about, I mean, a lot of us came out of the trades, and I mean, if you think about what they're used for, so you stand up that plate and you kick it over and you hit that in there, all right, it's not going to move. I can go down here, I'll hit this over in place, and it's there to hold stuff in place while you're constructing it. It's just like the cut-in bracing, that T-bracing. I know I blew a bunch of your minds when I showed you that ESR report on T-bracing. It's not to be used in lieu of bracing methods. So that little T-shaped Simpson strap that they use, you can't use it for bracing. Everybody calls it T-bracing, but it's not bracing. It's there to either A, keep the wall aligned when you stand it up, because you cut it in at a diagonal and you stand it up, and it keeps the wall from racking, or you use it in a basement to keep the studs aligned, where it's, there's no drywall or blocking in it. That's its purpose. It is not a bracing method. So, all right, fire blocking. We're getting close here. So, combustible construction, fire blocking shall be provided to cut off all concealed draft openings, both vertical and horizontal, to form effective barrier between stories and between top story and roof space. The integrity of fire blocking shall be maintained. And it shall be installed in the following locations. Oh God, there's a bunch of them. All right, so just briefly, concealed spaces where, let's see, that's vertically at ceiling and floor levels, horizontally at intervals not exceeding 10 feet. So vertically at floor levels. So if you've got studs that go up above your floor system, you can put your hand into the stud cavity and reach up into a floor, soffit, or wall system. There's supposed to be fire blocking there. If you've got a basement wall that has a foundation wall and studs spaced off of it, horizontally at intervals of 10 feet, there's supposed to be fire blocking that goes back to that wall, because we don't want fire ripping down behind that wall and running the room. Interconnections between concealed vertical horizontal spaces, soffits, drop ceilings, yeah, we just talked about that. Stair stringers, top and bottom of the run, around vents, pipes, ducts, cables, wires, and ceiling floor levels. Chimneys, fireplaces, we're going to see chapter 10. Cornices on two-family, that's something different. I was going to put that in here, but I don't think I did. But anyways, so here's our illustration. So here's our horizontal fire blocking. We don't want to be able to get our hand up into that floor system. We also don't want to have the fire ripping down behind those studs. Two simple ways. And if I'm talking to a framer, I'll say a real easy way for you to do this is to build that top plate with a 2x6. If you build the top plate with a 2x6, bump it against the foundation wall, then you can plumb it, because those walls are never plumbed. You can plumb the wall. You've got 1.5 inches of play there, or 2 inches of play, and you can plumb the wall, fasten the wall down. You've got the top done. All you got to do is run a shot of spray foam down through it, and you're done. Verticals, run a piece of pressure treated back in there. Spray foam.
That top plate and that vertical is contact with that masonry wall, that's pressure treated.
That's right. That's why I say it. Well, pressure treated 2x6. And then this, you could either run a pressure treated 2x4, or if it's tight, if it's fairly tight, just foam it. Use that orange fire foam. Rock wool. Rock wool can work. So here's an application here that they did, and you can see this space right here. We want to have that fire foamed or filled or stopped, and then this space right here between this stud and this wall needs to be sealed off somehow. Every 10 feet. Here's another one. Well, and to your point, look at this. Some of these are right in contact. Oops. Better get some felt back there. And you can see this one, they've actually added a piece of OSB on the top. So here's some applications here. I borrowed this from Internachi. I thought these were some really good illustrations showing the fire blocking at your soffit. So you've got your studs going up, you've got a built soffit, we've got fire blocking. Again, if you can put your hand in this space and put your hand in here, that's a problem. So if we've got fire blocking in here, that stops that movement of fire going up into this floor system, because look at what's open to this soffit, the entire floor system. You guys remember that house that burned down in Johns Creek several years ago? That girl, Lisa Left Eye Lopez, burned down that house, the ball player's house? Yep. I actually saw a fire report from that house. You know one of the things that was missing in it? Fire stopper.
Right, and also, she was barbecuing as use of the bathtub.
Well. Yep. And it pulled it up into those concealed spaces, and once it got in those concealed spaces, it just ran the house. So, yeah.
One place I feel like I never see it is on a vented gas fireplace, where the flue goes up through basically kind of that metal kind of covering. And that little gap right there is never sealed, where it kind of goes through, which is kind of that second.
Right. So there's a little bit of a catch-22 there. So I actually talked to one of the manufacturers when I was at Smyrna one time. I called them about that gap. And they said two things. They said, well, one thing with it is they actually designed that for that gap. Because what happens in a concealed space in a fire condition is it builds up pressure. So as that space is building up pressure, if you've got a single hole in it, the flame will come out, shoot out of that hole like a little blowtorch. And it's feeding fuel because of the oxygen. That space around that fire, that flue, well, it's all metal. So if it's drawing the fire to metal, it's metal to metal, and it's running up that pipe, it controls some of the movement of it because there's nothing for it to burn from there, because it's on metal. So that was their explanation. Some jurisdictions won't allow that to be filled. Now, if you actually go to the Fire Stop foam, the orange foam, it's rated for use in all Type 5 applications around all penetrations, including vents. So the fire foam is actually rated to be used in those applications. So some jurisdictions still won't allow it because they say, well, there's not supposed to be anything there. Okay. If you go to some of the manufacturers, they're still on that point of, we designed that space in there to give a relief for that fire so that it gets drawn to that and away from the wood. I don't know. I mean, you're kind of in a little bit of a catch-22 there. Yes, sir?
Is there any requirement for a chase around that pipe, the flue?
The insulated assembly, you have to have an insulation shield in the attic. But as far as a chase or anything, no, not
around like a fireplace chimney.
Fireplace chase, you can fire block that in two different ways. One, you could either have the floor system completely sealed off, or you could seal off around the perimeter of it for all the floor joists going through. So
what you know, you see the chimneys on the older houses that's on the exterior wall that come up, and you can look from the attic and see the top of the fireplace down below.
Yeah, that's supposed to have fire blocking in there.
All the way across to the brick.
The fire blocking is supposed to be at 10-foot intervals. Again, you got that 10-foot rule. So 10-foot intervals, we should have something there to break that.
Even though it's offset from the house.
Yeah, we want to have something in there to stop that.
Somehow you got to get over there, don't you?
Yep. Well, they should have done it when they built it. Now, if we're dealing with an existing house, at this point, there's no real way to get in there.
Yeah.
So, I mean, there's a point where it's like, yeah, I see it, but shoot, how's anybody gonna fix it?
Yeah.
And who's gonna fix it?
Well, what I recommend with those is at least to put a chase, you know, up in the attic, between that area and the attic, right? Because you can't get down in there to do anything.
That would be a good solution. I mean, at least it's closed off.
Yeah, it's more of concealing off the air space, right?
Yeah.
More than doing anything else.
Yep. Yes, sir.
On your diagram there on the left, the fire blocking soffit, isn't there supposed to be blocking between each of the joists at the front wall of that soffit? So you got that soffit's continuously open.
You mean here?
It's a horizontal space. And so if the fire's in the soffit, can't it just go right in each joist cavity if there's not fire blocking there?
Yeah, that's not a, I mean, you've got a point, but there's nothing in the code that would necessarily require that.
You're supposed to block that soffit.
Yeah, the soffit's got to be closed off every 10 feet. Kind of like the wall. So you'd have something in this soffit here that would run back, you know, maybe at a floor joist location, so it would be easy. But that's, you're just slowing the movement of the fire through it. All right, drop ceilings. Think about that for a second. Drop ceiling, acoustical ceiling. You stick your head up into an acoustical ceiling. Is there fire blocking here where this drywall ends? I don't know. Take a look. Yeah, probably not. I see you shaking your head. No. Yeah, probably not. But yeah, so those areas need to be closed off because you don't want to have that wall cavity open to that acoustical ceiling. Here's another one. Builder just missed it. Forgot about it. Now, there is two ways to fire block this. We could run a piece of, it's 2x6, a piece of 2x6 here, or we could run a piece of plywood on the back side of this. Now, I tell the guys a lot of times, if you know you're putting up a soffit around here, run plywood first. That way, if the electrician drills a hole through it, he's got to fix it. The plumber drills a hole through it, he's got to fix it. That way the plumber, or the framer isn't there trying to fit it up between the plumbing pipes and the electrical lines and doing notches and all this stuff. It'll make his life a whole lot easier. This is one that I see quite often. So we've got a ceiling line that comes down and it intersects the wall, not at the top plate, but down 4 or 6 inches from the top plates. So they've added this fire blocking here to close off that gap. Fire foam. Again, like I say, fire foam was rated for use. It's not for use on a rated assembly. But you can use it in all Type 5 construction. Type 5 construction is wood frame. So we can use fire foam in a wood structure, but we can't use it on a rated wall. So think about the townhouse wall. That wall between townhouses, you can't fire foam that. But you can fire foam penetrations, you can fire foam fire blocking. Those aren't rated. They're just blocks. They're to slow the movement of fire through the building. And there's also another one, UL 319. It's like a liquid mud. It's kind of like a brown colored caulk. It's fire caulk, quote unquote, but it's not really, it doesn't really carry a rating. It's like liquid mud. But the fire foam just works so well for any kind of gap or irregularity in the pipe or anything like that.
Are you talking about intumescent caulk?
No, it's so you've got the intumescent caulks, you've got the reds and the blues and the yellows. The other one is like a brown. And yeah, it was real popular for a little while before they allowed fire foam. I haven't really seen a whole lot of it, but it's like I say, it's like a liquid mud. It just doesn't burn. Now, I thought this was kind of interesting. So they did plywood to do their fire blocking. Yay! Anybody see a problem with the plywood?
Doesn't cover the joist space? Then go all the way across?
Mm-mm. Really?
Too thin?
It's 1/2 inch. Fire blocking materials. 2-inch nominal lumber, 2 thicknesses of 1-inch nominal lumber, 1 thickness of wood structural panel, 23-30 seconds. 23-30 seconds. So almost 3/4.
Not even 3/4.
Yeah, it's just shot. But I mean, 1/2 inch OSB is not fire blocking. Now, I mean, let's get right down to it. I mean, I've worked in 17 jurisdictions. If I get 1/2 inch OSB in there, I'm happy. You happy with it, Raul?
Yeah.
You happy with it? You happy? We're happy to see something get in there. So, I mean, Technically, half-inch OSB is not allowed, but most everybody, it's on the job site in plenty. It's everywhere. So, I mean, it's easy for these guys to get it. It's right there on the job site, and they can get it done. We've got something there. And then we've got, well, then 3/4 inch particle board, half-inch gypsum board, 1/4 inch cement-based mill board. Nobody wants to use hardy plank to do it, but I've seen some people use it. Batch of lengths of mineral wool, other approved materials, installed in such a manner to be securely retained in place. Now you mentioned rock wool earlier, and I've allowed rock wool. Insulation, oh, that doesn't say, this is cellulose. But insulation, how do you make it retained in place?
Packet.
It's got to be stuffed. So, I mean, I see these guys oftentimes, they'll put up a piece of insulation on there, they'll nail it on the bottom, and it's like, well, how's that going to stay there? Or they'll put one of those little support strips in there. Well, that ain't going to do nothing. Besides, that's not stopping the movement of smoke or heat through that. You know, if it's securely retained to stay in place, stuffed around things, I mean, that can potentially slow the movement of heat and fire and so forth. But yeah, I mean, so those are some other materials. Batch of lengths of mineral or glass fiber. So I mean, that's really talking about fiberglass. We can put fiberglass in there. But again, I mean, now this works for parallel rows of studs or staggered studs. I don't really run into this often, but you've seen two walls built where they have studs offset from one another. They can run that fiberglass insulation in there down through that wall to act as a fire break. Okay, I mean, I guess I could get along with that. Unfaced fiberglass, fill the entire cross-section of the wall cavity to a height of 16 inches. When piping or conduit, here it is right there, shall be packed tightly around the obstruction. So we want to see it tightly packed. Loose fill shall not be used as fire block unless tested in a manner demonstrate the ability to remain in place and retard the spread of fire and hot gases. Well, that even kind of goes for fiberglass too. I mean, if you think about it, if it's just sitting there, it's not going to stop hot gases or fire from going through it. I like this guy. Yeah. You like that fire blocking? That's foam. That ain't going to do nothing. Now, it's good for insulation purposes, but from a fire blocking standpoint, it's sorely inadequate.
It's a draft stop.
What's that?
Draft stop.
Yeah, well, even draft stopping has to be plywood. It's air stopping. Yeah. Now, I saw a guy one time, I had a builder one time, he was using T-ply. You guys all know what T-ply is? Yeah. The gray stuff that looks like cardboard with wax on it, basically. They use it for structural wall sheathing in some places. Ryland Homes used it, Ashton Woods used it for a while, Pulte used it for a while. I mean, it's a fairly common product. It's really good for air barriers behind bathtubs. What's that? Attic knee walls, it works really good for those as well. I saw a builder using that for fire blocking. And it was before I was really very familiar with the product. I said to him, I said, can you give me the instructions on the product? I mean, I'm just not familiar with it. I just need to read them. He said, sure, I'll email it to you. So he emails it to me. And then I go out the next day and I said, okay, I forget his name now, but I said, you need to put drywall over top of this fire blocking here. You got to put half-inch drywall here, and this is, you got to nail this out, and you got to do this. He goes, where are you getting all this stuff? I said, well, from the instructions you sent me. He said, well, what are you doing reading it? Just put it in the file. I was like, well, you sent it to me. I'm going to read it. I didn't want to insult you by not reading the product that you sent me. So it can be used as fire blocking if you put half-inch drywall or hardy plank behind it. Then it can be used as a fire block material. He's like, well, why don't I just use drywall? I said, well, that's probably a better option. So, you know, one of the point of that is when you run into these products that you're not used to or not familiar with, find out the instructions. Take down the serial number. You know, you saw the picture that I had of that MAB 15. That way I could prove, and I deleted a bunch of the other pictures. I had 6 pictures trying to get that clear enough so that I could read it. Because I wanted to be able to prove, A, what it was, and B, I could go back to the manufacturer's instructions and look it up and make sure that I was on the right product. What about this guy? Does he need fire blocking?
Nope. It's metal
No,
studs.
it's not combustible. Yeah. Whew. Now, I like this picture.
Paper face exposed.
That's blue ribbon.
Oh, it's fine, yeah.
I thought that was telling.
That's amazing.
Yep, we got a whole case of Pabst Blue Ribbon, and we got several sitting on the table. And this is how you insulate an attic.
Right.
Wow. Wow.
Billy Bob, hold my
Well,
beer and watch
it's
this.
certainly got an issue. You know, if you read the instructions right here, and if you had a couple of beers, you can't really read them anymore. But right here, this says,
Do not leave exposed.
This material will
Exactly.
burn.
do not leave exposed. And here's the other irony of that. Here in Georgia, 6 months out of the year, it's on the wrong side.
Right.
So, 6 months, every 6 months you gotta turn it around. If you contact John's Mansfield, they'll say here in Georgia, it should be all unfaced. So obviously we can see what this guy's doing. He's gonna have drywall running across here, down here, and down this knee wall. All of this paper is gonna be left exposed. That's gonna be a fire hazard down the road. It shouldn't be left exposed. And, you know, you're also building a potential moisture trap. You know, if I'm consulting with a client and they're getting ready to insulate, I'd say, just get unfaced. And under the new energy code, this is too thin. This is R13. This is ours, and you can't really see it in this picture right now. There, no, you can see that one a little bit. That's R19. For a second, it looked like a 3, but it's R19. Ceilings are required to be a minimum of what?
30.
30. There's no exception for slope ceilings. Slope ceilings are still required to be R30, just like flat ceilings. So, yeah, he's got a couple of issues there. Other than I think he's got a drinking problem.
Poor choice in beer.
Any questions? I'm not going to buy Pabst Blue Ribbon.
Fire blocking.
That's what I did.
Yes? Yes? Yep. Right. But if it's in the wall, there's nothing. Yes, sir. What's it supporting? You're talking about a cantilever, right? Oh, the foundation.
No, I just think anyone like
I mean, that's the rule of thumb, but I mean, if I run into that, I just throw it back to the engineer. You gotta have the engineer.
Code says it must be
Yeah.
What was that, sorry?
Yeah. But the old rule of thumb that we as framers always use, you know, if it's less, you know, 2/3 or a little more on it, it's probably okay. But to his point, you know, the code doesn't give any variation. It just says it has to be fully buried. But the other part of that is, what's it supporting? You know, and that's why I throw it back to an engineer, because if it's, let's say it's a 1-story garage and there's nothing up above it, it's probably gonna. If it's the first floor of a 3-story building and it's overhanging, you got a problem. So, yep. And then, thank you very much.